booklets before, so you should be somewhat familiar with the type of questions that we're going to be looking at, and we'll see how far we can get this afternoon in terms of addressing some of these questions. So I'm going to start with, before I actually start the question, I'm going to start with a little revision of sorts, just a little topic in algebra that you guys are probably familiar with. It's called the rule of three. The rule of three. So you can tell me in a minute if you're familiar with it, the rule of three. I'm sure you are, or maybe you don't know that name. So what it really means, or what I'm talking about really, is just what we call proportionality, right? It's just really proportionality in terms of fractions. Proportionality. I'm writing it here on the iPad. So are you guys seeing me writing on the iPad? Proportionality. All right, you can unmute yourself to respond to me. I like when I have a live audience and I have some kind of interaction. So you can always just unmute yourself. Okay, lovely. All right. So for example, a half, lovely. A half, somebody could give me an equivalent fraction for a half. Anyone? For a half, for example, a half is equal to what? Give me an example. There are infinitely many examples. Can you give me one example? I didn't hear you. What's that? Repeat. You're sounding very low. Let me turn up my mic just to make sure.
6.
All right, so
3,
half is the same as 3/6. Everybody agrees with that, right? Right, so this is what is called a proportion, right? A proportion is when we have equivalent fractions being equated. They're separated by an equal sign. So this is true. A half is equal to 3/6, or we can say 4/8, and we can say 17/34, and I can go on and go on, right? 56 divided by 112 is the same as a half. All right, everybody with me?
Yes, sir.
Yes, sir.
Right,
Yes, sir.
Yes, sir.
let us use this example on the screen. This it's a simple example, right? So this is true, right? Because we can write, and I'm just going to put in some arrows here. I'm going to put some arrows here. That arrow goes to that arrow, right? And you probably remember that from high school, from in class with teachers. So this is true because 1 times 6, all right? And then I'm going to put question mark 3 times 2, all right? And so 1 times 6 is equal to 6, and 3 times 2 is equal to 6. And this question mark now becomes equal, right? Because 6 is equal to 6. That's true, right? Because every number on the number line is unique, right? No two numbers are the same, right?
Yes, sir.
Right.
Yes, sir.
So when I write a half is equal to 3/6, I can say this is true because 1 times 6, if you notice my arrows here, 1 times 6 is the same as 3 times 2. And it is true. 1 times 6 gives us 6, and 3 times 2 gives us 6, and 6 is equal to 6. So this statement is true, right? And we call this what? Cross multiplying, correct?
Yes, sir.
Right, we call
Yes,
this
sir.
cross multiplying. And this is why you can cross multiply, right? It's cross multiplying really means that we have equivalent fractions. Always, no matter how algebraic it looks, how complicated it looks, all right? It means you're allowed to cross multiply, right? Because, I'm writing it here, because we have equivalent fractions, all right? So I'm gonna just be summarizing stuff here. I'm not gonna go into a lot of details because we do have a lot of time. All right, so I'm just reminding you of some stuff that you already know or should know. So that is why you're allowed to cross multiply, because we always have equivalent fractions. So now I'm gonna switch to a little algebra now to make it a little bit more generic. All right, make it a little bit more generic. So let me just change my color here. So let me use gray. So in general, I can write A over B is equal to what? C over D. All right, so we have two equivalent fractions, correct?
Yes, sir.
Yes, sir.
Can I cross multiply here as well? Can I do the same thing I did up top here? The same thing I did up top here? What can I write?
Yes, sir.
What can I write
A
here?
times D.
Equals to?
C times
C
D.
times B.
Beautiful. Beautiful. So I can write, this is true since what? A times D, which we call AD, is equal to what? B times C or C times B. It's commutative as the word we use. A times D is the same as D times A, and B times C is the same as C times B. So this is true. All right. So we can always do that. Now, let me go back and show you something now. So a half, I'm going back to the previous example on top there, which is a half equal 3/6, which you guys told me was true. So a half is equal to 3/6. So 2/1 is equal to what? So what did I do here? What did I do to 1/2? I have 1/2 here, and now I change it to what?
2/1. You flip it.
So what? And in order to keep the balance, what do I have to do?
Flip.
Flip the 3/6.
Reciprocate.
Right. So now it becomes what?
6/3.
6/3.
6/3.
3. Beautiful. Let us check it. What is 2/1? Let's check this. 2/1 is what? 2/1?
Sir, 2.
2. And what is
2, sir.
6/3?
2.
2, right? So
2 as well.
right, 2 as well. Beautiful. So
Sir,
2 is
worked.
equal to 2. So this makes sense, correct?
Yes, sir.
All right, so let's go back to the algebra now. So now I have A over B equals to C over D, correct?
Yes, sir.
So if I invert or reciprocate, or as you might say, flip one side, so I can write, so this implies, this sign here means implies, B over A then is equal to what?
D over C.
D over C, lovely. All right, beautiful. So you guys are doing very well so far. So let me get another page here so we can do some more examples of the same. All right. So this guy here that you see here and this guy here is the same guy and it's the same as that guy. So all of these are the same. All right. All of these are the same. This guy is the same as this guy is the same as this guy. Would you agree? They're all equal, correct?
Yes, sir.
All right.
Yes, sir.
So watch me again. Watch me again. I'm going to do another, keep going with the same. So again, notice if I cross multiply here, let me change that. Notice if I cross multiply here, what do I get? B times C, correct?
Yes, sir.
Yes,
If I
sir.
cross multiply, and if I cross multiply here on this side, what do I get? This
B
one.
times A.
B
B
times A or
times
A
A.
times, which is the same as this, correct?
Yes, sir.
Yes, sir.
Notice, so notice,
Yes,
look
sir.
at this and look at this. Even though they look different, it's the same thing, correct? A over B
Yes,
is
sir.
the same as C over D. Or it's the same as saying B over A is the same as D over C, right? So this is what I'm talking about. I'm talking about a rule of 3. What is this? Why do I use the word rule of 3 or the term rule of 3? Because in general, if I know any 3 of these quantities, if I know any 3 of these quantities, I'm going to change my color here so we can see. If I know any 3, for example, if I know B, if I know A, and if I know D, I can find C. That's why we use the terminology rule of 3. You don't have to use that terminology, but it works. All right. So if you notice, I have 4 items, right? 4 items. Okay. Let me change my color here. I'm trying to find another color that's different so we can see. Okay, green. So notice here, I have the B, the A, and the D highlighted. It means that I can find, if I know B and A and D, I can find the fourth one, which is C. That is why we use what? The term rule of 3. It means if I know if I have a proportion, anytime I have a proportion, something like this, something like this, something like this, something like this, they're all saying the same thing. They may look different, but anytime I have a proportion, right, which means I have 4 objects working with, if I know any 3 of them, I can find the fourth. So that is what I mean by the rule of 3. And this is very, very common throughout mathematics and science and algebra. Very, very common. It doesn't matter how advanced we are, we use it every single day. And you will see that we're going to be using it in some of the problems that may pop up as we go along. All right. So again, I'm going to be doing the same thing. So I'm just going to be, writing it in different ways. So again, I'm going to write A over B equal to what? B A over B equals to C over D,
over D.
right? I can make any one of these guys a subject of the formula, depending on which one I want to find. Let's say I want to find C. If I want to find C, then I can find C if I know A, B, and D. So I'm gonna make C the subject of the formula, right? Well, let me start with A. I'm gonna make A since we're pattern seeking animals. So let me start with A, and I'm gonna go to B next. I'm gonna go to C next, and I'm gonna go to D next. So I'm gonna make A the subject first. So let us cross multiply. So when I cross multiply here, what do I get? I get A times D. Stay with me now. A times D is equal to B times C, correct?
Yes, sir.
Yes, sir.
Correct. Remember now I want to make A the formula. So this implies or means that A is equal to what? I want to leave A alone on one side. So I'm going to divide both sides by what?
By D.
I divide both
D.
sides by D, right?
By D.
Right. I
Yes,
do that
sir.
because I have to keep the equation balanced, correct?
Yes, sir.
All right. And you understand that these guys here would cancel because D divided by D is 1. All right. So we have A times 1 on the left-hand side, which is just A. And on the right-hand side, we have B times C over D. So A is equal to B times C over D. All right. So now, if you notice, we can make A the subject. So we can find A if we know B, C, and D, correct?
Yes, sir.
Yes,
All right. I'm going to move on to B now. We're going to make B the subject. So again, I'm going to do the same thing. I'm going to cross multiply. So I'm going to label this number 1. In number 1, I made A the subject. In number 2, I'm going to make B the subject. Are you with me? I'm going to make B the subject this time, correct?
Yes,
Yes, sir.
All right, let's cross multiply again. So I have what? When I cross multiply here, I have A times D equals to B times C. That's always true, correct?
Times C.
Beautiful.
Yes,
So
sir.
A times D equals to B times C. What do I want to make the subject? I want to make B the subject, correct?
Yes, sir.
I want to leave B alone standing on one side, right? So what should I do here on the right-hand side, since that's where my B is?
Divide by C.
Beautiful. Divide both sides by C, by C. So I'm going to divide this side by C, and I do this by C. And when I do that, these cancel, correct? C divided by C is 1. That's what we mean by cancel, correct?
Yes, sir.
And so
Sir. Yes, sir.
we leave B alone
Yes, sir.
isolated, right? On standing alone.
Yes, sir.
He is now the subject of the formula, right? Or we use a fancy word sometimes called what? Transposition, correct?
Yes, sir.
Yes, sir.
So B is equal to what? A times D over C. So we have made B the subject now. And I can write it like this. I can reorient. It's the same thing as saying B is equal to AD over C, right? These two things are the same, correct? B is equal to that is the same
Yes,
thing I
sir.
have here, correct?
Yes, sir.
All right. So what is it saying? That's why I'm using the word rule of 3. Notice I can write B in terms of the other 3, correct? Yes or no? B in terms of the other 3. So I can find B in terms of A, D, and C, because it's A, B, C, and D that we're working with here. Make sense?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
In this example, B is a subject. In this example here, A is a subject, correct?
Yes, sir. Yes, sir.
We're going to do the
Yes,
same
sir.
thing for C and D now, right? Right. So why am I doing all of this? Because in different questions, the examiner may ask you for A, the examiner may ask you for B, the examiner may ask you for C, or the examiner may ask you for D. So you have to know how to what? How to reposition the objects that you want to find. All right. So let us go again and do the same thing again. We can start by cross multiplying here. AB equals to BC, right? So I'm going to write that AB is equal to B times AD, sorry, is equal to AD, A times D is equal to B times C. Now, what do I want to make the subject here this time? C, correct?
Yes, sir.
Yes, sir.
Let
Yes,
me
sir.
highlight C here. So what is C now? Tell me what C is.
C is AD divided by
AD
B.
divided by B.
Beautiful.
B.
You guys are so sharp. Very good. AD divided by B. All right. So I didn't show the step this time because we get the hang of it by now. So I just divide both sides by B, correct? Correct?
Yes, sir.
B
Yes, sir.
here. And so we have on this side AD over B, which is what I have here. Beautiful.
Yes, sir.
Yes, sir.
All right.
Yes,
So
sir.
we're going to do the same thing for D, lastly. The same thing for D, so I call this number 4. Again, we have AD equals to BC from the original. All right. So now I want to make what the subject? I want to make what? D the subject, correct?
Yes, sir.
What is D now? D is equal to what?
BC over A.
BC over A. So we observe exactly what's going on. We observe exactly what's going on. So what's going on here? We can make A the subject as you have here, or we can make B the subject as you have here, or we can make C the subject as you have here, and we can make D the subject as we have there. All right. So that's the rule of 3, and we use it very, very often, and it's a very, very, very common algebraic operation on your exams. All right. It's particular for your CSEC exams. Very, very common. So once you understand this, oops, let me undo that. Once you understand this, what's going on here, then you should be able to manipulate a lot of these simple equations. All right, so with that being said, let me get back to the question that is on the screen. All right, beautiful. So could someone read the question for me, please? Just one person, just read the
The
question.
diagram below shows a quadrilateral PQRS formed by joining two triangles, PQS and QRS. Calculate the length of QR.
All right, beautiful. And everybody know what a quadrilateral is? What's a quadrilateral? Simple expression.
A shape with 4 sides.
Right, it's a four-sided polygon, right? 4 sides, okay. All right, and this one is formed by combining 2 triangles, as you can see, right? This is one triangle, right?
Yes, sir.
We have another triangle
Yes,
there.
sir.
All right, so one of them
Yes,
is
sir.
QS, beautiful. PQS, form one triangle there, and the other triangle is formed by what? QRS, as you see me highlight there. All right, and they give us some information in the diagram, and it says calculate the length of QR. All right, so just some word of advice. When you are given these diagrams here, all right, you can only work with what you're given. Do not look at the picture and say, oh, this look like 60 degrees or this look like 90 degrees, because you do not know. Unless they tell you exactly what it is, then you don't know. You cannot assume that this is, you cannot guess this. You don't know what it is. This angle here that I'm marking on the screen, you don't know what it is. We don't know. We don't know the length of this side. It was not given. All right. This is not general. This is not drawn to scale. All right. The only thing you know is what is given. This is 16. This is 18. All right. This is 72 degrees. That angle S here. This angle S here is 25. This angle Q here is 43. This side length is 21. You only know what is given. Anything else has to be geometrically proven. All right. So don't make any assumptions. Don't say, this look like 90. You can't assume that, all right? So don't make that mistake. You can only work with what is there and given to you. Anything else you have to prove or show. Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So it says calculate the length of QR. All right. So first of all, you need to look at what is it that you're asked to do. And you're asked to find this side here, QR, which I'm highlighting. Correct?
Yes.
All right. Anybody
Sir.
want to
Yes.
tell me what is going through your mind when you think of finding, in order to answer this question? What is going through your mind? Anybody can tell me. What comes to your mind immediately?
Cosine rule.
All right.
Yes,
Good.
sir. Cosine rule.
All right. So somebody say sine rule, somebody say cosine rule. Is that what, did I hear that
Cosine
correct?
rule, sir.
All right. Good. All right. So why are you thinking of using the cosine rule? Let me ask that question.
Because you're
Sir,
given
because
two.
it has two sides and an angle.
All right, good. You guys has two sides and an angle. Is that a good reason? All right.
Oh,
Okay.
sir, and it's also a non-right angle triangle.
Repeat.
It's also a non-right angle triangle.
Beautiful. So I am very happy to hear that. So which triangle are we talking about, by the way? Because we didn't establish that as yet. Which triangle are we talking about?
QRS.
Right. So it looks
QRS, sir.
like we're
QRS.
working with this triangle here, which is QRS. So I'm going to try to highlight the triangle here so we can see a little bit better. Let me change my color here. So we're working with this triangle here, the one that is now in blue and red and yellow. Correct? That's the triangle we're working with, correct?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So that is what you should be focusing on when you get these questions. Even though you're given a quadrilateral, we don't need the entire quadrilateral in order to contemplate the side QR. QR is a side of the triangle QRS. So we're just working with that triangle. And some of you correctly said, oh, I'm thinking, sir, of using the cosine rule and the sine rule. And my question is, why are you thinking of using those rules? Why?
Sir, because if you're not on the label angle facing the label side, that can't work.
Because what?
You're not on the label angle facing the label side.
I didn't hear you. You're talking a little bit too fast.
Sir, me say if you're not having the label angle facing the label side, if you're not have a cosine, you use.
All right. So, for example, is this a right angle triangle? Let me ask a question.
No, sir.
No, sir. No, sir.
How
No,
do you
sir.
know that it's not a right angle triangle?
There's not a 90-degree angle, and it
Angle
didn't
in
state anywhere in the question that it was a right angle triangle.
Beautiful. All right. So first of all, well, let me ask you another question. I'm just playing around here. Is it possible that this is 90? This one that I marked, or is it possible that it is 90?
Yes, it is possible.
Right. Why is it? Well, you just don't know, right? But for now, you don't know, correct?
Yes, sir.
Right. So it could be
Yes,
90,
sir.
because maybe later on when you work it out, you get 90, correct? Right or wrong?
Right, sir.
But for now,
Right.
you have to assume that it is, you cannot
Yes.
assume that it is what? A right angle triangle. Because if it was a
9.
right angle triangle, we wouldn't need to think about the sine and the cosine rules, correct? What would we use if we were a right angle triangle? What would we be thinking of using if we knew for sure it was a right angle triangle?
The
Pythagoras
Pythagoras theorem.
Right. So maybe
Pythagoras theorem,
theorem
sir.
comes to mind.
Theorem.
Maybe if you need it, maybe. So you know that if it's right angle, you can apply Pythagoras theorem. Beautiful. You guys are correct in that sense, if necessary. So, but it's not right angled as far as you know. You're not sure. You don't know, so you cannot make that assumption. So you have to treat it like a what? A non-right angle triangle. But if it were a right angle triangle, you know you could apply the Pythagorean theorem, or you could use what we call what? The trig ratios, right or wrong?
The trig ratios. Right.
Right.
Sir. Yes, sir. Yes, sir.
What
Right,
the
sir.
trig ratios? What are the trig ratios again? I'm just jotting up the top here. What are the trig ratios again?
Sine, cos, and tan.
Sine, cos, tangent.
tangent.
And the trig ratios, and we have, right? So we have an angle. So I'm just gonna do a little quick thing here. Just draw a right angle triangle, for example, and I'm gonna call this angle here theta. All right, I'm gonna call that angle here theta. So this is 90 degrees, this one, and so I'm gonna write this side here. All right, what is this side here called? It's called the hypotenuse, right?
Yes, sir.
And
Yes, sir.
with respect to theta, this angle is theta, and this angle here is, I'm going to call this angle here
Opposite.
alpha. All right. I'm going to call one theta and call one angle alpha. So we have two angles, two acute angles apart from the right angle, correct?
Yes, sir.
Yes, sir.
And why are they acute?
Yes, sir.
Why do they have to be acute?
Because there's the 90 degrees.
Because this is already 90. So what is left over between these two is what? What's the sum of the angles of a triangle?
180 degree.
180
So
degrees.
if this is
180
already,
degrees.
if this is already 90, what is left? What is left between these two?
90 degrees.
These two have to share the 90,
90,
correct?
sir.
Yes, sir.
So I can, so it means that alpha plus theta must be equal to 90 degrees, right or wrong?
Right.
Sir.
Right, that means that's why we know they're acute. That means that because both of these are going to be less than, individually less than 90, correct?
Yes, sir.
All right, good. That's why I said they have to be acute. Beautiful. All right, so this side here is called the hypotenuse, correct?
Yes, sir.
Yes, sir.
All right.
Yes,
so
sir.
Let me know, what is this side called? This side.
Opposite side.
The opposite side.
Opposite side, sir. Opposite side.
All right. And what is this side called?
Adjacent.
Adjacent.
Adjacent. Adjacent.
Sure about that? I'm not so
Yes.
sure.
Yes, sir.
Yes,
I'm
sir.
not sure.
Adjacent, sir. Yes, sir. Yes,
Sir,
sir.
Sir's not sure. Sir hears something and sir's not sure. Sir said, what is this side here? And everybody say opposite. And sir said, what is this side? And everybody say adjacent. And sir saying, sir is not sure. Sir needs some more information. So can somebody tell me why sir is not sure that your answer is correct?
Sir, because in this case, we don't have the angle that we're supposed to find.
We have a right angle triangle. We have a right angle triangle, correct? It's a right angle triangle. Oops, sorry, let me use my marker here. This is a right angle triangle. I've said that because this is 90, correct? So a right angle triangle, we normally give the sides name. And we're throwing out some words here. We're throwing out the words hypotenuse. We're throwing out the words opposite. And we're throwing out the words adjacent, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Those are the
Yes,
words
sir.
we use for a right angle triangle. That is good. That is true. But somebody said to me that this is opposite, and somebody said to me that this is adjacent. And I am saying that I am not so sure. I'm not so convinced. So why is it that sir have a problem? So I'm gonna go ahead and write what you say opposite right here, so all right, and somebody say adjacent.
Sir, because the opposite side also have an angle.
Ah, beautiful.
Well,
I
an
know what
angle
you're trying to
labeled.
say. What she's trying
Yes,
to
sir.
say is that the opposite is relative. You have to have a reference angle. So opposite, you can't just say opposite. It is opposite to what? Opposite to which angle? So we have two acute angles here, alpha and theta. Is this opposite to alpha or opposite to theta?
Opposite to theta.
Opposite to theta.
Opposite, because a cross
sir.
from theta. Beauty. That is why
Yes, sir.
that is why sir have a problem. Sir wanted to hear opposite to theta. So this side here, let me highlight it again. This side here is opposite to theta. Make sense?
Yes, sir.
So
Yes,
this
sir.
side,
Yes, sir.
but this side is also adjacent as well. Let me write it. Watch me now. Are you going to agree with me? This side here is also an adjacent side. But adjacent to what?
Alpha.
Alpha. It is right next
Alpha,
to
sir.
alpha. This side here,
Yes,
this
sir.
side, let me change the color so you can see a little bit better. Let me change the color here. All right, let me change it to green or something like that. So this side, I'm going to mark it green. So the green side is opposite to theta while it is next to alpha. And we use the word for next to is adjacent. So that makes sense?
Yes, sir.
Yes, sir.
So what I want you to remember, guys, that when you use the word for a right angle triangle, when we speak of trig ratios, when you use the words opposite and adjacent, it's always with respect to the angle that you are referencing. Does that make sense?
Yes, sir.
Sir.
Yes, sir.
All right, so don't forget that, because if you just jump and say opposite and you just pick an angle, you may be wrong, right? Beautiful.
Yes, sir.
All right, so let's go back now. This side now, so this side here, this side now, which I'm gonna give it a different color here. Let me do it purple, just so we can see a little bit better. So this purple side here, now is now what? Adjacent to what angle?
Adjacent to theta.
Alpha.
Theta.
Theta. Because it's next to it, right beside it, correct?
Yes, sir.
And
Yes,
this
sir.
purple side is opposite to which angle?
To alpha.
Alpha.
All right, beautiful. So it's across from alpha. So this is what I want you to take away and remember. Do not forget this. Opposite and adjacent in a right angle triangle are relative to the angle that we are speaking of. The angle that
Sir,
we
so
are
based
referencing.
on how the question is structured, you would
Yes,
just know which one to use on which side.
absolutely. Absolutely. That's my point.
Okay.
That's my point. That's why when we just started, you just tell me opposite. I wasn't satisfied. You understand?
Yes, sir.
Because as you can see, I have two opposites here, right or wrong?
Right.
But opposite to
Right.
what? One of them is opposite to alpha, one is opposite
On
to
opposite to
theta.
the theta.
Beautiful. So depending on the question, you have to pick the angle that you're referencing. Make sense?
Yes, sir.
Yes,
All right,
sir.
so let's go back to, so that's for a right angle triangle, but it so happens that this is not obviously a right angle triangle. So now we're gonna have to either use the sine rule based on what you guys would have touched on in your syllabuses, or the what? Or the cosine rule, the sine rule or the cosine rule. So what I'm gonna do is quickly jot in the corner here, jot on the corner here, the sine rule. Sine rule, quickly jotting it down. Anybody want to tell me what the sine rule says? So, let me draw a picture. So I'm gonna draw a picture. Let me use, for example, all right, let me use this picture here. I'm just gonna draw any triangle here. I'm gonna label this A, I'm gonna label this B, and I'm gonna label this C. For the angles, I'm using capital letters. And from the sides, I'm gonna use common letter. So side common B is subtended by angle B. So that's the word we use. This side here, all right, subtends this angle here, B. This side subtends this angle. So this angle here corresponds to this side. It's across from it or opposite to it. Similarly, if this is angle A right here, then I'm going to label correspondingly this side common A and over here common C. All right, so based on this setup here that we see in this little picture here that I have just put here in the corner, what does the sine rule say? Anybody can remind me, please?
Is it A?
Side A over
A
sine
over sine
angle A
A equal B over
equals
sine
over
B.
sine B.
Beautiful. All right. So it says that A over sine of now the angle A equal to B over what? Sine of B equal to C over sine of C. And you see, you know what we're talking about in the picture here. We know what capital C, capital B, capital A are. They are the angles. And we know what the common letters represent, the side lengths. All right. Good. So please notice that these are three equations. All right. Even though I wrote it like this, yes, we have three equations, correct?
Yes,
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 sir.
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 To show
Yes,
you,
sir.
I'm going to highlight and show you what I'm talking about. Let me change my color here. Oops. I changed my color here. So one equation is that you can use A over sine A equal to B over sine B. That's one equation, correct?
Yes, sir.
Yes, sir.
Right?
Yes, sir.
You can just, so what you notice here, since you see, remember when I started this class, what you notice here, just this remind you of what I started the class with. What did I start the class with? This guy
Sir,
here
the
in the
cross
yellow box.
multiply.
This guy in the yellow box look like who? Who I started the class with? Let me go back to it.
Sir, the
Oops.
cross multiply or the rule of two.
Ah, yes, it looks like this guy, right or wrong?
Right.
Right.
Right, sir. You see why I started with this, because it is important. It comes into play a lot. All right. Beautiful. So I'm Happy you guys are seeing that. Let me change my color here and give you another equation because we have 3 equations. One of them is I use yellow here. All right, let me change my color here so you can see it a little bit better. I'm going to use green. Or I can write A over sine A equal to C over sine C. That's another equation, right? In green.
Yes, sir. Can you have B over sine B to equal C over
Yes,
sine C?
that's the third one. So we have 2 so far. The yellow and the green equations. Everybody see that?
Yes, sir.
Yes, sir.
And if you look at the green one, let's look at the green one, it looks like it's another proportion, right or wrong?
So the proportion of each one
It's another proportion. You know what a proportion is? 2 fractions that are equal, right?
Yes, sir.
Over sine A equal to C over sine C, correct? All right. Lovely.
Yes, sir.
What is my third equation that young man just said a while ago? I'm going to change my color here. What's my third equation?
B over sine B equals C over sine C.
Beautiful. I'm going to use orange here for that one, all right? I'm going to use orange. You can see it now in orange, the third equation.
Yes, sir.
All right. And all 3 equations are proportions, right or wrong?
Yes, sir.
Right.
Right.
So we can
Hello.
cross multiply and do all of that fancy stuff, right or wrong?
Right, sir.
Right.
And we can
Right.
find and how many quantities we have in each of these equations. Notice how many variables we have. Let me just use the orange as an example. We have B here, which is a side length. We have an angle B. We have side length C, and angle C. So we have the 4 quantities, right or wrong?
Yes, sir.
Which is what we were looking at here. The 4
Right.
quantities A, B, C, and D. Remember? You see the comparison?
Yes.
All right. So that is all we're going to be doing, and we're solving for these unknowns. So if we were to use the sine rule, that would be the situation. Let us look at this cosine rule now. Cosine rule. Cosine rule. I'm going to write it right here. Cosine rule. Let's remind ourselves. Cosine rule. What does the cosine rule say? Anybody wants to tell me?
A square
A square equal B
equal
square
B
plus
square
C
plus C
minus
square
2AB
minus 2BC
Minus 2
cos
BC
A
cos A.
plus A.
Beautiful. 2BC cos of the angle A, correct? Or B squared equal to what? We have alternatives, right? B squared equal
Yes,
to what?
sir.
Other 2. So you already choose B here. So it's easy to remember, you know. Once you know this one, you know all of them, right or wrong? 'Cause here you have A, and the other 2 are B and C and B and C. You notice? You see and then A here correspond to the side A here. This A
Yes.
correspond to this A here, which is the subject of the formula almost. Make sense?
Yes, sir.
Yes, sir.
All right, so it's easy to remember. Once you remember one of them, the other 2 are easy. You don't have to try to memorize it too much. It just follows. So if I use B here, if I use B right here, then what are the other 2 I'm going to write inside here? This is going to be what? The other 2 are what? A and what?
A plus C,
Square
A
plus
square
C.
minus
Times what?
2
AC
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 Plus what?
plus B plus
cos
angle
C.
B.
Beautiful. And the other one is what now? C squared equal to what?
B square
B
plus A
square plus
square
A square
Right.
minus
minus
2
2BA
2BA
or AB doesn't matter, right?
cos
B or AB
C.
is the
plus
same thing. Cos
C.
what? C.
C.
Beautiful. So it depends on what you want to find, right? Yeah? Depending on what you want to find. So notice now, let us look at this. Look at this, what we have here. Let us go back to look at the cosine rule as an example. Since you guys correctly said, sir, in this question, we're going to use the cosine rule. But let us look at why. Let us try to understand why. Because you don't know what kind of question you're going to get, and you have to sometimes reason it out. You have to think it through a little bit. All right? And I don't want you to go in the exam just relying just on formulas. Because sometimes you might go in with a formula in your head, and the formula, you don't see where the formula helps you. So you have to reason it out a little bit. But you know the sine rule, and you know the cosine rule. But take a look at this. Let us look at any one of them. All right, let's look at this one. It doesn't matter which one. All of them are really saying the same thing more or less. All right, so let's look at this one, right, which I have marked yellow. Let's look at it. What do we have in this cosine rule formula? We have what? A, we have B, and we have C, and we have the angle A. We have four quantities, right or wrong?
Right, sir.
Right.
Right, sir.
Now we have three sides. Notice the A, the B, and the C, which is what is here in the picture, which are the A, B, C, the side lengths, right? And we have an angle,
Yes, sir.
one angle, right or wrong?
Yes, sir.
Right.
All right, one angle. And it's the same thing for the next two. We have A, B, and C, and what? An angle. Different angle here. We have A, B, and C here, and one angle. So all of them are behaving the same way. Three sides, one angle. All right. And so that is going to help you to decide when do I want to what? When do I want to use the what? Cosine rule for a non-right
Cosine rule.
triangle. When do I want to use the sine rule? Now look at the sine
Sine
rule.
rule.
Let's go back and look at the sine rule. Look at any one of them for the sine rule. Like let's look at the orange one, for example. If you notice, for the sine rule, what we have in the sine rule, use the orange one. Just use the orange one because all three of them, right? What we have? We have two sides, right or wrong?
Two
Yeah, two
sides.
sides and two
Right.
angles.
We have two angles, right or wrong? Because this is
Right.
side and side, angle and angle.
Right.
Just focus on the orange one alone, because all of them are the same, right? Just focus on the orange one alone. All right? So we have side and side and angle. Make sense?
Yes,
Yes,
sir.
sir.
Yes, sir.
Got the yellow one. Same thing. Side and side and what? Angle and angle. So two angles, two sides. Make sense?
Yes, sir.
Yes, sir.
So that is what kind of
Yes, sir.
determines which one of them you use based on the nature of the question that is presented to you. All right. So let me just jot down. I don't know if I may have time for that. Let me just jot it down quickly. All right. Just to remind ourselves of when we use the sine rule. All right. So I'm just going to jot it down here. All right. Let me have a little space here. I'm going to write it down. The sine rule. Sine rule. Oops. All right. So we use the sine rule as we just demonstrated. We use the sine rule and we have when what? When we have two sides.
Two
and
sides and
angles,
two
right? And it's not the included angle, right? So two sides. So sine rule, two sides. I'm just jotting it down. Two sides and an angle. Oops. Go back. All right. Two sides and an angle. And an angle known. All right. So we know one angle and want another angle. Does that make sense?
Yes, sir.
Yes,
Makes
sir.
sense.
Yes,
It makes
sir.
sense. Now look, let me go again. Look at the orange box. Look at the orange box, right? We have two sides, rule of three coming into picture again, right? So we have four quantities, B, sine B, C, sine C. These are four quantities, right? Proportionality. So if we know any three of them, we can find the fourth, which is what I started out with right here. If we know any three, we can find the fourth. That's what I call the rule of three, correct?
Yes, sir.
Yes, sir.
If we know side and side and one angle, pay attention, watch the orange box. If we know side and side and one angle, so if let's say we know B, C, and angle C, we can find angle B. Make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right. This is what this bullet is saying. Two sides and a known angle, we can find the other angle. Make sense?
Yes, sir.
Yes, sir.
Just simple maths. Just simple looking at something like this. That's all we're doing, really and truly. All right, let's go again. When can we use the sine rule? So similarly, I'm going to write another bullet here for the use of the sine rule to remind us. All right. And to be honest, you don't have to try to remember this to go on an exam. You don't need to. All you have to do is just look at it. If you just observe it and analyze it and think about what I wrote here. You think about what I have here. If I use this as an example, oh, I have four quantities, right? A, B, C, and D. If I know any three of them, I can find the fourth one. Make sense?
Yes, sir.
Yes,
You don't
sir.
have to try to
Yes, sir.
memorize memorize all of this stuff and full up your head with stuff. You can just look at it and say, if I know three of them, I can find the fourth by just using what? Cross multiplication and algebra and juggling it around and making the subject of the formula and all of that good stuff, right? Because that is what you're doing really, and that's legitimate. So let me just write it down here just for have it on the record. So if we have two angles and one side, two angles and one side, and want another side. Does that make sense? For using the sine rule? So again,
Yes, sir.
we
Yes,
have
sir.
that
Yes,
means
sir.
we know B and we know C. So we know these two. Look at the orange box. We know this and we know this, and we know one side. So we can find C, correct? If I know these three, I can find C, which is a side, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Or if I know these two angles and I know C, I can find B, correct?
Yes, sir.
Yes, sir.
Which is what this second bullet is saying. So you have two angles on one side, you can find the next side. All right? Beautiful. Let me write down now for the cosine rule. When we use the cosine rule. So the cosine rule, as we went through here, this is the cosine rule. We can use the cosine rule. Let me jot it down right here. The cosine rule. All right. Three sides known. So this is easy. Three sides known. Find any angle. Does that make sense? Look at it. Look at the formula. Does that make sense? If you know these three sides, you can find the fourth, the unknown, right or wrong?
Right.
Yes, sir.
If you know A, B, and C, then you can find big A. If you know little a, little b, little c, only one thing that is not known is capital A. Make sense?
Yes, sir.
Same thing here.
Yes, sir.
Same thing here. If you know B, A, and C, you can find capital B. And similarly, you can find capital C. Make sense?
Yes, sir. Yes, sir.
That
Yes,
is why
sir.
that is what we're saying right here for the cosine rule. All right, that is what we're saying right there for the cosine rule. So three sides known, you can find any angle. And you guys were on the money a while ago when we look at the question. Two sides, all right, and included angle. So in this case, it has to be included angle. And included angle. And we want another side. We want another side. So that's another time we can use what? The cosine rule. We want another side. So let us analyze this. All right, a little bit. Let us analyze it. So what am I saying there? I am saying that we can use the cosine rule if we have two sides. So for example, we have two sides, okay? We have B and C, which are two sides, right? Pay attention, I'm using this one right here. Let's say we have side B and side C, right? And we have this angle here, A, then we can find side A. Does that make sense?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Similarly, if we
sir.
have A and C right here, and we have angle B, we can find little b. Make sense?
Yes, sir.
Yes, sir.
Yes, sir.
And we can do the same thing here. So that is what I'm saying up here. We have two sides and the included angle. We can find the next side. So let's get back to the question now. So the question was, we want to find QR. All right. And we have this side, and the 25 years the included angle, right or wrong?
Right.
Right. Beautiful. So let us apply the cosine rule, and you guys correctly said it, so I don't have to drill on it anymore because you spotted it early. So let me just write something here. I'm going to write a cosine rule for this particular triangle, which is the QRS triangle. So if this is S, I'm going to call this little s. This side here, if this is Q, I'm going to call this side here the Q. And if this is R, I'm going to call this R. Does that make sense?
Yes, sir.
Yes, sir.
All right. Because notice, this is S, so this is little s. This angle here is Q, so this side here is Q, little q. And this angle here is R, so the opposite, it is, right, subtended by little r over here. And we know what little r is. It's given us 18, this is given us 16, and so on and so forth. The included angle here, caught between Q and R, is 25. So as you appropriately said, we're going to use the cosine rule. So let's apply the cosine rule here in terms of S. All right. So we can write S squared is equal to what? R
Sorry,
squared
Q squared. But, yeah.
plus Q squared minus 2RQ cosine of the angle,
Plus
included angle,
S.
and cos S. Does that make sense?
Yes, sir.
What we have here
Yes.
is the same thing that we have up here. All right, it's just we change the letters. Make sense?
Yes, sir.
Yes,
All
sir.
right. So let us solve this problem now. We're just going to drop in what we know now, right?
Yes, sir.
All right. So we have what we know. And what we know is that S squared is equal to, let me write that now, equal to, what is R?
18 square.
18.
That's 18 squared. What's Q?
16 square.
16 square.
16 square.
Minus 2. Use your brackets nicely. R is what? 18. Q is what?
18
16.
times
16.
60
Cosine of what? 25 degrees, correct?
Yes,
Yes,
sir.
sir.
25. Yes,
All
sir.
right. So once you reach this stage of the problem, basically over. We just have to be careful now and finish it nicely and make sure you don't make any mistakes. And importantly, make sure you have your calculator with you. And you know how to use your calculator. You know how to find cosine on the calculator. Make sure that your calculator is in degrees, right?
Yes,
Because
sir.
the calculator is not on degrees,
Yes, sir.
and it is in some other measure. You're gonna get the wrong answer. But there's another measure called radian measure. There's another measure called gradient measure. You don't have to worry about those right now. But if the calculator is set on it's not set on degrees, it normally have a little D there at the top of the calculator. Make sure the calculator that you're using in the exam has degrees. So when you press cos of 50, it is measuring the 50 in degrees. You understand?
Yes, sir.
Because if it is not degrees, it's going to give you the wrong answer. Okay? And it's not because you don't know what you're doing. It's because you have the calculator giving you some other information. All right?
Yes, sir.
Yes, sir.
So now be very careful and take your time. I'm gonna do this properly. Because this is what I want you to do in the exam, so you don't make any mistakes. All right. And what is 18 squared? 18 squared, you go on the calculator, you can do that on the calculator pretty easily. So make sure you
324.
practice.
24.
324.
And what's 16
24.
squared? 16 squared?
256.
256.
Beautiful. And what is 2 times 18 times 16?
576.
576.
76.
Right. And I'm gonna leave this as and I'm gonna put bracket here. What is cos of 25 degrees?
0.906.
0.906 307787.
I'll take 3 decimal places on now, because that's reasonable. We can't write so many decimal places, all right? So we'll use 3. 3 is reasonable, all right? Good. So that's it. And let us just finish this nicely. So what is this? This is 580 minus, right? And this one, what is 576 times 0.906? Somebody tell me.
522.033.
522. All right. We're just going to call it 522 for now. Right? 522 point what? Tell me what they said. Point what?
033.
0.90.
Beautiful. And we subtract this, what we get? 580 minus that gives us 57 point something.
57.96.
57.8.
So remember, S squared is equal to that. But we want to find S. So what we have to do to find S?
Square root.
It is square
Square
root. Because S is a side length and length is always positive, so we don't need to worry about the negative, right? Square root, right? Square root, that's a positive one. So it's square root of 57.97. What's the square root of 51.7?
7.61
7.61
Before approximately
centimeter.
7.61. And you can write in, since we finished, you can write in your meters, right? It's in meters, yes.
Yes, sir.
All right, since we finished, you can put in the meters at the end. You don't have to put, don't put it in these stages because it's going to be very messy, all right? When you finish, you just put it in at the end because we understand that you're working with meters all the way, okay? Beautiful.
Yes, sir.
Yes, sir.
All right, so that's applying the cosine rule. All right, lovely. You guys are doing well so far. I'm very happy to see that. Very happy to see that. All right, so let us see. What else? We're going to move on to the next question. So it says the bearing of P from S is 205 degrees, so on and so forth. All right. So I'm going to write quickly. I'm going to write a few little things on the, let me get another page here, plus another page, and I'll make some notes here quickly to remind us, okay? So I'm going to draw a picture here quickly, just to remind us, because we're doing bearings now. This question here is a bearing question, so I'm going to do a quick little bearing revision. Is that okay?
Yes, sir.
All right.
Yes, sir.
Quick little bearing revision.
Yes.
I'm going to draw 3 points here. So, right, and then this one here, and then another one here. Oops. All right. Oops. Let me do that again. All right. So I have 3 points here. All right. And I'm going to label this one here A. I'm going to label this one here B. And I'm going to label this one here C. All right. Good. And what I'm going to do here right now, I'm just going to draw. All right. Some lines there going north. Going north. All of them going north. All right. Beautiful. All right. Lovely. So I'm going to label this guy here. So this guy here is a north line at A. And this here is a north line at B. All right, everybody can do that. You can draw at any point in space, you can draw a north line, right? Just a line pointing north as I've done in the picture. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Good. So let me just give you some quick little notes here. What color I'm going to use there. All right, so quickly, the bearing of B from A is the angle. Once you understand this, then the story is over, guys. Is the angle measured in a clockwise direction. Everybody know what a clockwise direction is?
Yes, sir.
Right, the clock,
Yes, sir.
clock on the wall, the clock on your hand, your watch. If you have one of those, if your watch is not digital, that is, right? It turns in a clockwise direction. That's what we call clockwise direction, right? It spins in a clockwise direction. From the north line, north line at A to B. All right, good. So that is the definition of bearing. So let's read it again. Let's read it again. The bearing of B from A, and the operative word here, the most important word here, or words here, is this word here, from. Notice I said B from A. I didn't say A from B. Make sense?
Yes, sir.
So
Yes,
it's
sir.
from A. Wherever it is from, that's where you're going to start. So if it says from A, it means I'm going to start at A, measuring from A. If it says from B, I'm going to start measuring from B. So I'm going to go ahead now and use and draw in my bearing. All right. Use this color. All right. So this guy here which I've done green, which I just drew in. This guy here, the green guy, is a bearing of B from A. So notice this angle here, notice I go in a clockwise direction, correct? I start here at A, right? I start because A is along here, right? A is right here. I drew a north line. I will start measuring from the north line in this direction, not in this direction. Not in this direction, that's anti-clockwise, in this direction. So this is my north line through A, the north line through A. This is the north line through B. This is the north line through C. Is everybody with me?
Yes, sir.
So the bearing of B from A, it says the bearing of B from A. So this is B over here, you know, and B is right here, all right? And A, when it says from A, you always start measuring in a clockwise direction from the north line through A. That is what the from A mean. If it said from B, they would start at the north line, this direction, from the north line through B. If it said from C, again, north line through C, this direction, from the north line through C. Is everybody with me?
Yes, sir.
Yes, sir.
Good. So let's focus on this definition. The bearing of B from A is the angle measured in the clockwise direction from the north line at A or through A to B. So notice now, something I want to point out. Let's focus on A and B just for a minute. A and B. So A is right here and B is right here, correct? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
And this is a bearing from B, bearing of B from A, correct? B from A.
Yes, sir.
Well, I started
sir.
from the north line to A. Beautiful. All right. Now, I have a point A and I have a point B, correct?
Yes, sir.
Yes, sir.
Yes,
I
sir.
connect 2 points. What do I get?
Get a straight line.
I get a line segment, right? I get a line
Line
segment.
segment.
Yes,
Beautiful.
sir.
Now, full question I'm asking you, but I'm trying to make a point. What is this distance AB? This distance, the length of this. What's that distance? Do you know what it is?
No, sir.
180.
Oh, you
180,
don't
sir.
know. You don't know. I didn't tell you. So you don't know. It's just you can measure it, right?
Yes, sir.
All right. Watch me now. Pay attention. Watch what I'm doing. I'm doing something. I want to drive my point. Suppose suppose I put B here. I'm gonna call this B2 just to distinguish it. If I am gonna move the point B. See, B is right here, right around, right? And I move
Right.
B here. What happened? The distance changes, right around.
Right.
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 In this case, the distance gets shorter, right around. Yes or no? Distance is shorter than this original
yes,
distance, right?
Yes, sir. Distance
Yes,
is
sir.
shorter.
All right, watch me now.
Yeah.
Watch me now. Don't. I want you to stay with me for a second. I'm gonna extend the line over here. I'm gonna extend the line over here. I'm gonna put another B here. I'm gonna call it B3 just to distinguish them, right? So I move B. So notice I'm moving B now. I'm moving B. B was originally here, and then I move B. It came a little bit closer to A, right or wrong?
Right.
Right.
Right. And here I move it a bit further away, right?
Yes,
But
sir.
notice, but my B is sitting along this line here, this line segment always. Now, let me ask you the most important question. When I move the B from here to here, which is I call B2, does this angle change?
No, sir.
No,
No,
sir.
sir.
Beautiful. That is
No,
what I want
sir.
to notice. The angle did not change. As long as B is on this line, the angle is not going to change. The bearing is not going to change, right or wrong?
Right.
Right.
So the bearing of B3, which is this guy, from A is the same as a bearing of B from A is the same as a bearing of B2 from A. This angle doesn't change as long as B sits along this line. Make sense?
Yes, sir.
All right. So I want to keep that in the back of your heads. There's a reason why I'm pointing it out, because sometimes you may be told that what? You may be given this distance. Sometimes you'll be given this distance. You have to understand that what? This distance can change. The bearing doesn't change, but the distance can change. For a given bearing, the distance between 2 points can change. Make sense?
Yes, sir.
Yes, sir.
The AB distance can change while the bearing remains the same. Everybody with me?
Yes, sir.
All right, I want you to keep that in the back of your heads, because some questions will require that you understand and appreciate that fact. All right? Good. So let me get rid of the B3 and the B2 so that you don't get too confused with too much stuff. Right? All right, good. So I'm back to my original picture. All right. So I'm going to use a different color now, and you're going to tell me what I just drew in. All right? You're going to tell me. So I'm going to start right here, and I'm going to do that I get. Can tell me what purple is. Somebody tell me what purple is. What did I just draw in? Purple.
An alternate angle.
No. I want you
Bearing
to talk
of
to me in
A
terms.
from B.
We're talking about bearings here, my
Bearing
friend.
of A
Bearings.
from B.
Bearing of
Bearing
A
of
from
A
B.
from B.
Beautiful. What happened? Where did I start? Where did I
So you
start?
start at B.
North
B.
Start
line
at
You
to
B.
started
B.
at B.
North
Started at
line
B,
at
sir.
B. Yes or no? So it has to be what?
Yes,
From,
sir.
right? And I came around right to this, and this is A right here, because A, B sits along the same line segment, right? So I started at the north line and
Yes.
came around here. So this is what, as you correctly said, tell me what it is. It is a bearing of what?
A from B.
A from B.
Bearing of?
A
A
from
from
B.
B.
No, it's not. B, A, sorry. Oh, my bad. That's correct. I left bearing off. Let me write it. Bearing off. A from B. Beautiful. All right, so I'm going to draw in. I wanted to do something else. I'm going to connect these dots here. I'm going to draw another line here connecting these guys. Beautiful. Lovely. All right, I forgot to do that. Good. That's correct, what you said. All right, now I'm going to draw in, I'm going to change my color and draw in another kind of different color that you can easily make out, like maybe the blue here. So watch me now. Watch me now. Blue. What is blue?
A bearing of C from B.
You guys are bearing of what? Repeat.
Bearing
C
of C
from
from
B.
B.
Bearing of C from
C
where?
from B.
From B.
Beautiful. Remember, the from is always from which north line you start. The north line through what? Point. So in this case, we started at the blue guy, which is this guy right here, started at the north line through B. So it is going to be from B, just like our right here is from B. All right. Now I'm going to do another one. Change my color here. So we're getting the hang of this thing quite nicely. Let me change my color here, and we do another one. Which color am I going to use this time? Maybe I'll use let me use this pink. All right, let me use a magenta for you so we can see this one.
Yes.
All right. So I'm going to draw in this magenta one here. So tell me what magenta is. What is that?
Bearing of
A
B
bearing of
from
C.
B from
C.
C.
Bearing of what?
B from
B
C.
From
from
C.
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 Beautiful. Bearing of B. Write it for you. Bearing of B from what? C. Again,
C.
we started at the north line through C, correct?
Yes, sir.
Yes, sir.
And we went around and stopped right there along this line. And this line here, remember we started at C. So if you started at C right here, that's where the north line is. And then along this line, C went all the way up to what? To B, right? So it is a bearing of B from C.
E.
And that is it.
C.
All right, beautiful. So let me just remind you of some key points here about bearings. All right, everybody with me so far? Everybody okay?
Class big man.
Yes, sir.
Yes, sir. Yes, sir.
Let me just write those.
Class big man.
Turn off your mic if you're not talking in class. All right, so one key point here to remind you of. Always, let me write it here. I'm just writing it for your benefit. You can go back later and rewatch this. Always start from the what? Always start from where?
The north point.
North
The
line.
The
north
north
point.
line.
Right, through whatever point, right? In
Yes,
which
sir.
direction? Which direction? In a
Clockwise direction.
clockwise
Clockwise
direction.
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 Beautiful. That is number one. Number two, focus on where you are. Focus on where you are measuring. Focus on where you're measuring the bearing from. I'm not going to write the word from in capital letters, all right? Because that word is very important, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Bearing language and elevation and depression language, the word from is very important because you have to know from where or to where. You get it?
Yes, sir.
All right. And number three point I want to point out, bearings tend to be written in 3 digits. All right. Okay. And I can say here before the decimal,
Yes, sir.
because sometimes there might be a decimal place involved before the decimal place. That's what DP means. All right. So, for example, 047 degrees, not 47 degrees. All right. Not 47 degrees. So, so when I say decimal, it could be 47.1. You still say 047.1. You understand? If it's a decimal, right?
Yes, sir.
So this is what we use. All right. Where is it? Let me get my ticket here. This is what we want. We don't want this. All right. So because remember,
Yes,
if
sir.
it's bearings, we are always starting from the north, the north line, correct? And if it's a regular angle,
Yes, sir.
if it's a regular angle in a regular triangle, we're not necessarily starting from the north line. So that's why we have to distinguish between bearing language and regular degree values, okay?
Yes, sir.
All right. So these are very three important points that capitalize or capture what we're talking about. So with that being said, let's go back now to the question. The bearing of P from S is 200. Oh, I forgot something. That I want to share with you because it's going to make your life much easier. So I have another key point here that I want to share with you. Let me get another page. Go back to the question. There's something called back bearing. So we make back bearing. Back bearing. So let me highlight that. Back bearing. What do we mean by back bearing? Let me tell you. If we know the bearing, and this is a simple geometry, but it's very easy for you. So I want you to keep this in mind and remember for some of your questions. Okay, if you know this, you're gonna make. Are you gonna see it in a minute in one of in the example? If you understand back bearing, then some of your calculations are very easy. So if we know the bearing of A from B, let's say A from B, then the back bearing. So let me highlight this guy here. Let me change my color here, underline it. The back bearing. All right. Let me go back to my brown. So if we know the bearing of A from B, then the back bearing is the bearing to get back to B from A. So it's very simple. So look at it. So if we have A from B, then B from A is called the back bearing. Make sense?
Yes, sir.
Yes, sir.
Right. So A from B,
Like the opposite.
the opposite is like saying the opposite. We can use that. That's fine. So A from B is called the bearing. Then B from A is a back bearing. Or if you have B from A first, then A from B is a back bearing. Make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Let's draw a picture of that quickly. All right, let me use which color here. Let's draw a picture. So if I have B here and I have A here, for example, so I'm going to call this B. I'm going to call this A. I'm going to connect the line A to B. All right, let me do that. That's not very straight. All right. All right, and then if I'm it said from B, right? The first part said from B. It said from B, right? Yes, all right? From B, right?
Yes, sir.
Yes.
It said from B, what does that mean?
From B.
From B means that what?
It-
North line
It's
must go.
coming from B.
North line
North
must
line
go
is
on
coming
from
from
B.
B.
right?
From B.
Good,
Yes,
good.
sir.
Beautiful. Right. So let me change my color here so we can see it much clearer. All right. So this guy here is now what? This is A from B. Make sense?
Yes,
Yes,
sir.
sir.
All right. All right. No. So what is the back bearing now?
So the back bearing is B
From
from
A.
A.
So if you say,
B from A.
if you say back bearing, B from A, what? So from where? From where?
From A.
What does that mean?
A.
From A mean what? What does that mean?
The north
I mean,
line
the north
starts
line
from
is
A.
drawn from A.
That line must be drawn through A, correct?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right, and then I'm going to start at that north line, correct?
Yes, sir.
Yes, sir.
B from A mean I'm going to start here and go all the way around and stop there. So that green guy there is what? B from A. Make sense?
Yes, sir.
All right. And we can use simple geometry now and work out the bearing, the back bearing, once we know the bearing. All right? Because we know that the total revolution, the total thing is 360 degrees. Yes or no?
Yes,
It's a
sir.
circle. That's a circle,
Yes,
right?
sir.
And that's
Yes,
a circle. Right. So with that being said, here's a simple way of remembering it. I'm going to just give you two little notes here. And you're going to see how easy it is. Very, very easy to remember. So you see what's going on there. You understand what I mean by back bearing. So once you understand that, then I'm going to write this so you can remember very, very easily. So bearing A from B is greater than 180 degrees, right? Then subtract 180 degrees to get B from A. So let me put a bullet here. So what am I saying? If you are given the bearing of A from B, then the back bearing is B from A, correct?
Yes, sir.
Yes, sir.
Yes, sir.
If the bearing is bigger than 180, to get the back bearing, because it's bigger, and think about it, if it's bigger, we're going to what? Subtract, right? We're going to subtract 180,
Yes, sir.
subtract the 180 to get the back bearing. All right, and then now, the other one, as you're going to see, that's very easy in a minute. If you are given the bearing, same bearing now of A from B, same thing, but this time it is less than 180 degrees. Then all you do now is what? Is add the 180. You add 180 degrees to get the back bearing, which is what? B from A. So, very simple. Let me repeat. You have a bearing, right? If your bearing is bigger than 180, to get the back bearing, you subtract the 180. Okay? Bigger. So think about it. If it's bigger, you have excess. So you subtract the 180. So if it is bigger than 180, then you subtract the 180. if it is smaller than 180, to get the back bearing, you add the 180. Because smaller, you want more. So you add the 180. So in both cases, to get the back bearing, it depends on what the original bearing is. If the original bearing is bigger than 180, you subtract the 180. If the original bearing is smaller than 180, to get the back bearing, you what? You add the 180. So this is what I'm saying in both of these bullets. Make sense?
Yes, sir.
Yes, sir.
Easy to remember, right? All right. And look at the picture. Does it make sense in the picture? Because this angle here, just geometric, this angle is smaller than 180 or bigger than 180. This angle here.
Small.
Smaller than 180.
All right. And the back bearing is bigger than 180?
Yes, sir.
Yes,
Right.
sir.
Yes, sir.
Yes, sir.
So to get from the smaller to the back, the bigger, you'd have to add the 180. So 180 plus something, right or wrong?
Right.
Right, sir.
Sense? All right. And then to get from here, if you start with this one, the green one, is it bigger than 180 based on the picture? It's bigger than 180, right?
Yes, sir.
So to get to
Yes,
this
sir.
one, you have to subtract the 180. Make sense? To get it smaller. Make sense?
Yes, sir.
All right. So you can remember, this is very easy to remember. Nothing changes. If it is bigger than 180, because it's bigger, think about it, you have extra, so you subtract. Make sense? And if it is smaller than 180, think about it, you need some more, so you add. And all you're adding is a 180 both times. So it's very easy to remember in terms of back bearing. But you don't have to even remember it. You can work it out for yourself, because the picture is right there that we drew, and we just realized that it makes sense. All right? So with that being said, let's get back to the question at hand, which is this guy here. Good. So the bearing of P from S is 205 degrees. So keep that in your mind. We're gonna go back to the picture. The bearing of P from S. Is that what it said? You guys remember?
Yes, sir.
Yes, sir.
Yes, sir.
Bearing of P from S. So tell me what to do on this picture now. I want to draw that in on the picture. The bearing of P from S. What should I draw?
Sir, the line must go through
The
P.
north line at
The north
P.
line.
Sorry, repeat. The north line should be where?
The north line at P.
No, it says the bearing of P from S. That's what it said. Let me go
North
back.
line from S.
Read what it
Is
says.
to P.
See it here, guys. See it here. Green. What it say?
The bearing of P from S.
From
From
S.
where? From where?
Is
S.
of P
What does that
from
mean?
S.
What does that mean? Tell me now.
This is
The north line to start from S.
Ah,
Through
so
S.
it must be drawn through S. Make sense?
Yes.
Yes,
All
sir.
right. That's what we did a while ago. That's what we did a while ago. So I'm going to draw a north line through S. I'm going to call it north line at S. Make sense? So,
Yes, sir.
and so now what? So it says what? P from S, right?
Yes, sir.
Good.
Yes, sir.
So tell me now, where I'm going to draw the angle now. Tell me, so where I should start? Right here, right? Tell me where I should stop. I should come around to where? Here?
Sir, go around to P, sir.
All right. Oops. So this angle here. Does that look correct?
Yes, sir.
Yes, sir.
Make sense? That's what we did a while ago, right? In the previous example.
Yes,
Sir.
sir.
Yes, sir.
And you should do this in the exam. You label this 205 degrees. That's what the man tell you. Right or wrong?
Right.
Right,
Alright.
sir.
So we haven't done the question yet. Now. All we do is just write in information that he gave us, right? So let's just see what the question is saying now. Determine the bearing of R from S. R from S. And again, you must notice it's 1 mark. That means it's not too much work. You hear? When you say 1 mark, it means that it's not too much work. If you're doing too much
Okay,
work,
sir.
you're probably doing the wrong thing. You hear?
Okay, sir.
All right? So you
Yes,
must pay
sir.
attention. Because sometimes you can do the question more than one way. Sometimes you have longer ways and you have shorter ways. Sometimes if you're doing the longer way and it's just 1 mark, maybe you're not using the shortest route. You understand? But nonetheless, it says R from S. R from S. So where is R from S? That's what he asked. R from S. Let me go back. R from S. Question says R from S. Let me highlight that in blue. R from S, right?
Yes, sir.
R
Yes,
from
sir.
S. So what does that tell me? Where I
Yes,
should
sir.
start? Where I should start? Tell me where I should start.
S.
At
Yes.
S.
Start from
Sir,
S.
start at
Beautiful.
S.
I'm gonna use a yellow color here or orange color. And where I should stop? Tell me, should I go here?
R.
R.
No, sir, at
No.
R.
All right, that's wrong.
Angle R.
Tell me where I should go.
At R, sir.
All right. So from there to there.
Yes, sir.
All right.
Yes, sir.
That's what I want.
Yes, sir.
So that orange guy is the bearing of what? R from what?
S.
S.
That orange guy is R from S, correct?
Yes, sir.
Everybody following?
Yes, sir.
All right.
Yes, sir.
Think about it, is 1 mark. And you must draw the scene on your diagram, guys, in your exam. And you look at it now and say, he gave me some information and he asked me for some information. Obviously, what he gave me can help me to find what I want. Can that make sense?
Yes, sir.
Guys, a 1 mark question, I'm saying, is not a lot of work. Look at that picture there. Look at the picture. The blue and the orange we just drawing a while ago. And tell me if you can work out R from S without doing much work.
Yes, sir.
Yes, sir.
Yes, sir.
Tell me, what is it?
205 minus 72
-1.
and minus 25.
Beautiful. So you notice, everybody notice, right, that this angle here, which is a bearing that we drew in the blue guy, all right, P from S, 205, includes this guy, right or wrong? The bearing of R from S, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
We know this piece here, sir, right? We know this piece here, sir, yes or no?
Yes, sir.
Yes,
What is
sir.
this angle? What is this angle here?
97 degrees.
72 plus 25, which is 97. Correct? And
Yes, sir.
Yes, sir.
beautiful. So we can find this piece then, which is the orange piece. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir. All right.
Yes, sir.
So let us write the answer in for you. So the answer here, right? 1 mark. That's why it's only worth 1 mark. So it is 205 degrees minus, what is it? The 72 plus the 25, right?
Yes, 25.
Yes, sir.
Yes, sir.
So this is equal to 205 minus what? 97 degrees. And this is equal to what? 100 and?
108.
108 degrees.
That is why you see it's not much work. That's why it was only worth 1 mark. You understand?
Yes.
Yes, sir.
Beautiful. All right. I'm writing on the bottom here, so I don't want to confuse anybody. All right, 108 degrees. And I'll erase this piece here. All right, good. Everybody okay so far?
Yes, sir.
Yes,
All
sir.
right. Let's move to the next question now. So you notice it says S from P. And it's worth 2 marks. That means I'm expecting you to do a little bit more work, right?
Yes, sir.
But hold on. When want again? S from where?
S
Yes,
from
From
P.
P.
From P.
What did he
Sir,
give
so you're
us?
not,
What
so
did he
you're
give us
not
in the
then I go
question?
start from P.
What did he give us in the question?
P from S is
P from S is 205.
And what is S from P? What's the word for S from P? The term for S from P?
Back bearing.
Back
Back
bearing.
bearing, sir.
Bearing, sir.
Back
Back
bearing.
bearing.
And the bearing is greater than 180.
Yes,
Yes,
sir.
sir.
205
Yes,
greater.
sir.
So that mean the back bearing mean to find the back bearing, which is S from P. What we must do?
you have to
Subtract.
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 Subtract, sir.
Right. So let's answer the question. So the answer is the back bearing of P from S is S from P. That is, right, Are we going 205 degrees?
Yes,
Minus
sir.
180 degrees. And this is equal to what?
25 degrees.
25.
And we're done. Isn't that easy? Because you know what a back bearing is now, right? And you realize this back bearing is asking you for, right?
Yes, sir.
Yes, sir.
Yes,
All right.
sir.
Now, let's go back. Let me go back. Okay. All right. So, everybody okay with that? Is that the only way we can find the angle, though? Is that the only way we can find it?
No,
No,
sir.
No, there are other ways, right or wrong?
Right.
All right. So we did it the easy way a while ago with the back bearing, right? Let's try to find another way. What was the question asking you for? The question was asking you for what? S from P, right or wrong?
Right.
Right,
Right.
sir.
S from
Right.
P. So let us do it. Let us do S from P. I'm back at the picture. Stay now. I'm not doing anything new. Same stuff we're doing all over again. S from P. What does S from P mean?
So you start at
Starting
P
at
and
P.
stop at
Start
S.
at
All right.
Then
Start with the
circle
north
it.
line where? Through P.
P.
Yes, sir.
This is north
P and
line.
stop at S.
We're doing the same question, we're just doing it a different way. You understand?
Yes, sir.
Yes, sir.
Good. So what you notice about the two north lines? They're what? They're parallel, right or wrong?
Right.
Right.
All right. The two north lines are parallel. That's very important. Good. Now, we got what I'm trying. And so, which angle do we want, though? We want what? S from P. Remember that, right? So, how do I do
Yes, sir.
S from P is this guy here, right?
Yes, sir.
Yes, sir.
Yes, sir.
This is S from P. Everybody agree with me?
Yes.
Yes, sir.
I've
Yes,
done
sir.
nothing new, guys. Same thing we're doing from morning. S from P is that guy. So we're just trying to do this question a different way. We did the back bearing part already, which is much easier. I'm saying that you have other ways of doing the question because we have a lot of information. Now, anybody look at the picture now. Everybody look at the picture. Remember, you know this guy, 205. We want to find this guy, the green guy, and you have this guy. Tell me what I can write in. Tell me what you know based on the information you have here. Take a good look at the picture and keep in mind that these lines here are parallel. The north lines are parallel to each other. Take your time, no problem.
Sir, sir, S from P is on a straight line, which means it's 180. And you would minus the 205 from the 180 to get the 25.
Beautiful. But okay, but let's do it as a more straightforward way. If this angle here is 205, do we know this angle here?
Yes, sir.
What is this angle here?
155.
In other words, tell me how you get it. I don't really care about the answer. You have to subtract
360
what?
minus
360
205.
minus
Minus this, because it's a
205.
full circle.
205.
And what was the answer you said? 150 what?
155.
155. Let me write it in for you. 155 degrees. So this angle here is 155. And what the young lady just said a while ago, because these lines are
Angles.
parallel, this is parallel to this, then these are called co-interior angles. You ever heard of that term, co-interior?
Yes, sir.
Yes, sir.
This is line
Yes,
is called
sir.
this is called a transversal because these are parallel. So when you have any two parallel lines like that, and you draw a line across them like that, it's called a transversal. So this is actually a transversal because these are parallel. You understand?
Yes, sir.
Interior angles are supplementary. That means they add up to 180 degrees. So if this is 155, then this angle here has to be what? 25 degrees.
25.
And we get the same answer like before with the back bearing. Make sense?
Yes, sir.
Yes, sir.
So there
sir.
are several ways we could approach this question. That's my point. All right. Any which way you do it would have been fine. It's just that the back bearing was a little bit shorter. Correct?
Yes, sir.
All right. Lovely stuff. Let's move along.
Sir, the answer that be 025.
Answer, yes. Let me write it properly down here for you. All right. Back bearing 025. Thank you very much. Very lovely observation, my friend. Because we're dealing with bearing, so it's 025. The answer is 025. Okay? All right. Beautiful stuff. Everybody good?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Lovely stuff. Lovely stuff. So let's go back to another, go on to another example now. So this time we can probably move a little bit faster because it's the same type of question here. So it looks like some bearing to me because once I see, as I look at this question, I'm seeing north line, right or wrong?
Right.
I'm seeing north line. So right away, bearings start come to my mind. You know the man doesn't know about bearing yet. As I look at it, I'm thinking I'm going to ask me something about bearings in a minute, maybe. All right, let us see what it says. The diagram below shows a triangular field, LMP. Everybody see that?
Yes, sir.
On a horizontal ground. That means the ground is just flat, right? It's not hilly. I don't have any bumps. Just imagine a perfectly flat ground, okay? It's on a horizontal ground. All right?
Yes, sir.
Good. And the man give you the three sides of this triangle. Yes or no?
Yes, sir.
Let me ask you a question, a foolful question. We did this already in this class. If you see three sides to a triangle and you know the three sides, what comes to your mind almost automatically?
Cosine. Cosine rule.
Cosine rule.
There you go. You can't miss. Right away. That should come to your mind. Maybe you don't need to know. Maybe you do. I don't know. Right? But that must come to your mind because you know three sides. You know the cosine rules. Cosine rule what? Involves three sides and an angle. Yes or no?
Yes, sir.
All right. So let's see what the question is saying. Calculate value of angle MLP. So let's always mark the angle that you want. MLP. Which one I want? MLRP. Which one I want?
L. Angle L.
I want this angle here, which I have labeled pink or magenta. All right. That's the one I want. Beautiful. That's the one I want. Calculate the value of that. The diagram below that calculate the value of angle MLP. All right. Good. So we want angle L. We want angle L, right? In the triangle, okay? Good. Let me write it. In the triangle, all right? In the triangle. All right. So, can we find L?
Yes, sir.
How we can find L easily?
Cosine rule.
Cosine rule. All right, so we use the cosine rule. All right, so we're gonna do that quickly, very quickly. All right, so what did it say? Tell me what to write quickly. Cosine rule.
L square equal M square plus P square minus 2MP cos
Right.
L.
Lovely. So just give me the numbers now. Look at it. What is my
180
L squared? 100 and what? 80 squared
square
equal to
120
squared
plus
plus what?
180 plus 150 square.
Minus 2
plus 150 square.
2 times 150, 120 times 150, the same R.
150
And the cos of what?
cos of
L.
L.
Angle L.
Angle L.
Cos of
big
angle
L.
L.
Make sense?
Yes, sir.
Yes, sir.
Just reminding you guys, the L is across from the 180. The L is across from the 180, right?
Yes, sir.
Right? The 180 subtends an angle L, right? The 150 corresponds to this M. Make sense? And the 120 corresponds to the P, correct?
Yes, sir.
So in this case, this is the formula we use because we start with the 180. Suppose, say it me now, don't lose track. Suppose I put 150 here. Over here, 150 squared. What should I have inside here if I put 150 here? 150 squared. Tell me.
You'd have 180 and then 120 over the side.
120.
What should be here if I put 150 here? Squared.
Sure, 180 and 120.
No.
And then
Sir,
the
cos
angle,
M.
the angle.
Cos
If I put
M.
150 here, it's
Cos M.
180.
Cos
Cos
M.
M.
Here.
Cos
Cos of
M.
what? M. Beautiful. and I put 120 here squared. What should I put? Angle should I put here?
Cos P.
Beautiful. That is what I want to pay attention to, because the man could have asked you for any of the three angles, right or wrong?
Right, sir.
Right.
You have to know how to set up your cosine formula, because remember you have options, right? You have options. I'm gonna go back up. I'm showing you. I'm going back up. Where is it? Where is it? Where is it? It's right here. There it is. Yes? So it depends on which one you want, right?
Yes, sir.
All right. The A, B, or the C, or in this case, we call them L, M, and P. All right? L, M, and P. Good. So let us work this out quickly. 180 squared is what? Somebody tell me what's 180 squared?
180 times 180.
Which is
32,400.
32,400 equal to 120 squared.
14,400.
All right, cos L. So let's do our maths, right? This is equal to
36,900.
this is minus 4,500 equal to minus 36,000 cos L. All right, good. So in case you're not, this guy here is the same as this guy and this guy, right? Okay. So when you carry these over to the left-hand side, you subtract and you get minus 4,500. Okay, are you with me?
Yes, sir.
And we have this alone left on this side. If you add this and this and subtract it from 32,400, you get negative 4,500. All right. You know what? Let me write it out properly for you. So this is equal to 32,400 is equal. What is this? 0, 0, 5 and 4, 9, right? 1, 2, 6, 2 and 1, 3. Correct?
Yes, sir.
And then you subtract 36,900 from 32,400. 32,400 minus 36,900 gives you what? Negative 4,500, okay? Equal to minus 36,000.
Yes, sir.
All right? Or cos L. And you want to make cos L the subject, right? Or the formula, because it's L we want, right? So cos L
Yes,
is
sir.
equal to minus
Yes, sir.
4,500 divided by minus 36,000, correct? Correct?
Yes, sir.
Yes, sir.
And so these zeros cancel each other out. And then 45 and 30 and 36, I look like I can use what now? 9 5s, I can use 9. Let's use 9. I'm just doing it without a calculator. So 9 into 45 is what? 5 times, right? And 9 into 36 is what? 9 4, so that's 40 I have in the denominator, right? And then 5 into 5, 1. 5 into what? 48 times. And the negative divided by negative is positive, right? So this is equal to
Yes, sir.
is equal to 1/8. Everybody with me?
Yes, sir.
Yes, sir.
Yes,
All right.
sir.
If you put it in the calculator, it will tell you that answer anyway. And 1/8 in decimal, you don't have to do this, is 0.125. You can try to remember that, okay? In decimal is 0.125.
Yes, sir.
So 1L now, you have to use it. No, this is where you have to pay attention. You have to use the inverse
Cos
cosine
inverse.
Cos inverse on the time. Cos inverse by decimal.
of 1/8 on the calculator, or you put in 1.125 on the calculator, and if you're going to give you something like what? Anybody who can tell me what you get on the calculator? Practice, please.
Yes, sir. Yes, sir.
82.8
Sir,
degrees.
82.8 degrees, sir.
82.8 degrees.
It's about 82.82 degrees. Beautiful. Lovely. So I'm going to write that in right here. 82.82 degrees. All right. Something like that. All right. Lovely. So we know what L is. Lovely, lovely, lovely. Everybody okay so far? That's why it was worth 3 marks.
Yes,
right?
sir.
You have to do a little calculation, but it was nothing difficult. All right. Once you don't make any mistakes, it should be good. Okay.
Yes, sir.
Lovely stuff. Let us move on now to the next question. And there it is, as expected, bearings, because I saw that knot line there in the picture. So I know that he was going to come with some bearing stuff. So first of all, what did he say? He said the bearing of what?
The bearing of P from A. P from L is
P
120.
from
L.
L.
From L.
Tell me what I should do in the picture now. We always draw that in the picture so you know exactly what's going
So
on.
you already did here, north line already there, L.
So P from where? Remind me.
L.
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 So in north line
Sir,
already
not
there,
line
L.
already there, L, sir.
Ah, the man do the job from you. Tell me so what I should do now. Where I should stop? Where I
At
should
P.
draw
P.
P?
What P?
At L.
So start
At P,
here
sir.
and go all the
Start
way
at
to here, so?
The clock.
No,
No,
sir.
sir.
yes.
No,
Oh,
sir.
Round to
all
P.
right. So let me stop. So that
All
is
the way around to P.
so I must go all the way around to the
P.
line that connects P and L, right or
P.
wrong?
Right, sir.
Right.
So
Right.
we start at L and him say P, so it's a line that connect P and L, which is PL. Make sense?
Yes, sir.
Yes.
Yes, sir.
So we know we can go around to here. So that is what the man gave us. And what him said was 200 how much?
210.
So you're
Wasn't
right.
it?
210 degrees. You're right on your thing. 210 degrees. Lovely. All right. Let's see what I'm asking for now. Find the bearing of what?
M from
M
L.
from L.
M from L. How many marks?
1.
That means it's not a lot of work, correct?
Yes, sir.
Yes, sir.
All right, so let's go back up. M from L. Let us draw a thing though, just to make sure we're doing the right thing. Let us draw an M from where? L. M from where?
L.
Where am I
L.
start? Where am I start? Right here?
L.
Start with L.
Go around to there, right?
Yes, sir.
Yes, sir.
This is M from L, correct?
Yes, sir.
Correct?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So for 1 mark, look at that picture. Can you work out what M from L is without doing much work?
Yes,
Yes,
sir.
sir.
Tell me what it
210
is.
minus 82.8.
Beautiful. It is very obvious, which is equal to what? 210 degrees minus the 82.8.
Which is 127.18.
All right. So that's 127.18, as you said correctly. 127.18 degrees. Lovely stuff. Lovely stuff. So it's 210 degrees minus the 82.82, which is equal to 127.18 degrees. All right. So with the three digits, so we're good. So that's a bearing. All right. All right. Everybody okay?
Yes, sir.
All right. Lovely. Next question now. Calculate the value of what?
Angle NLP
M.
and hence find the bearing of L from P.
P. All right. So let's go back up to the picture. Angle NLP. That's what he said? Yes? NLP?
Yes, sir.
Let's go back to the picture. Oh, am I passing the picture? There it is. There it is. There it is. Angle what? NLP. So is which angle is that now?
M.
So the north line is from P.
Is this one? This is NLP, right?
Yes.
This is N, right? NLP, right?
Yes, sir.
So this is the angle he wants, right? Yes?
Yes, sir.
What is this angle, by the way? That's easy. What's this angle?
Circle is a back bearing and then find the angle for that.
No, we don't need to do so much work, man. It's simple. Simple. Look at it again. You don't even need to mention back bearing. You know this angle, right?
210 from the 360.
Right, that's all. You don't need to, don't overthink it. You know this, and that is a full circle, right?
Yes, sir.
So we can find this piece, right?
Yes, sir.
Yes, sir.
You don't have to be thinking about
from
anything like that. It's just simple geometry, right? So let us write this.
150. Yes, sir.
So this guy here is what? 360 minus what?
210.
210.
210.
150.
And that's equal to what?
150
degrees.
degrees. 150 degrees.
Right. I remember it's 2 marks question work, you know. That means it's not much work because we already do half of the work, finding the 150 already, right? Good. What is it? What am saying we want now? The bearing of what?
So the bearing from
Of
L
L
from
from
P.
P.
L from
L
P.
from
So,
P.
see, I am being very disciplined, you know. Him say bearing of L from where?
P.
P.
So him say from P, what does that mean? I'm going to do
Sure,
it.
the north
So,
line starts like P.
north
North
line
line
from
through P.
P.
You can't miss if you do that every time. Just do the right thing. So I'm going to draw the north line through P right there. You seeing it in yellow?
Yes, sir.
All right. Okay, so what him said the bearing of what? L from?
Of L from P.
So that means I'm going to start here and come around to here, correct?
Yes, sir.
Are you guys, this is the same question like last question, except that in this question, him kind of lead us on and tell us what to do. But it's the same question like a while ago we did with the transversal, remember? Because these lines are parallel, yes or no? These
Yes.
are parallel. So this is a transversal. So this angle here are co-interior angles, correct?
Yes,
Yes,
sir.
sir.
And
Yes,
co-interior
sir.
angles are what? Supplementary. That means they add up to 180, correct?
Yes, sir.
If this is
So
150,
it's the
what is this?
one, so the 150 from the 180, and you'll have 30.
I'll give you the 30. That is why it's not a lot of work, you know. That's why it's only 2 marks. That's why sometimes you have to just check yourself and say, am I doing too much work? All right. And you realize we just did 2 steps, we get the 2 marks. All right. It's not the only way of doing it, but easiest way based on information. That's 30 degrees. So you can write in the answer. All right. Okay. So what is the answer? 30 degrees, 0 is a bearing. So you have to write as 0, 30 degrees. Okay. But once you put these in, you see, you're gonna get marks for these, you know. You show this on your graph, you get marks, okay? You get the marks, okay? Because this is your working out. You understand?
Yes, sir.
Yes, sir.
You get all the marks. Once I see this, I'm gonna mark you and you're gonna get all the marks, okay? All right, lovely stuff. Everybody good?
Yes, sir.
All
Yes,
right,
sir.
all right. Okay, all right. So let us see now. Let us do this question here, and then we get back to the next one if we have time, because the other one is also a bearing one. And I think we're very good with our bearings right now. This is also bearing. So this one here is angle of depression and elevation question. So I want to cover that before we go. So let me give you a little bit of notes, all right, on angle of depression and elevation before we go. So let me get a new page maybe here. All right, let me get a new page right here. All right. So let me draw a line right here. All right, good. And I am not a good draftsman. I'm going to draw another line here. All right. So what am I going to do here? So I am going to draw a little man here. It's a little man. These are his legs, right? So his legs are on the ground, and these are his hands. Oops. These are his hands like this, right? So I'm not drawing very good. Okay, all right, good. I'm gonna do this. Da, 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 da. Gonna do this. Beautiful. All right. So stay with me now. I'm just trying to make sure we get some stuff down. All right. So this guy here, this is the ground. Oops. This is the ground. The ground, and this is a horizontal line. This is a horizontal line. All right. So the man is standing on the ground, and this man, all right, is eyes. This is his line of sight. Right here is his line of sight. Line of sight. So remember, the man has some height, right or wrong? You're standing like this, you have some height, right or wrong? Yes, you have some height, yes?
Yes, sir.
Your foot is on the ground, and this is your, if you're looking, if your head is not up or down and you're looking straight ahead in this direction, then this is your line of sight. Just imagine like a laser beam from your eye, as long as your head is looking straight ahead, right? So this is your line of sight. So this guy here is parallel to this guy. So your line of sight is parallel to the ground. Are you with me? Which is a horizontal line. Do you agree?
Yes, sir.
All right. So I want you to keep that in mind. The line of sight is really the ground shifted upwards. It's like you take the ground and you just shift it upwards. All right. You can shift it, right? You can draw any amount of parallel lines. You just shift it upwards in space. You just slide them up. All right. So your line of sight is like the ground shifted upwards. Make sense? Are you following me so far?
Yes, sir.
All right, cool. All right,
Yes, sir.
I'm going to draw on another picture, draw another little picture here quickly. Another little picture. Use green here. So this is A, and this is B. And this here is my horizontal. All right, this is my horizontal line. All right, that's my horizontal line, similar to this horizontal line, okay? So this angle here, I'm going to use. So I'm going to write what I mean now by angle of elevation. So angle of elevation of B from A is the acute angle. An acute angle, remember, is what? Smaller than 90, yes? Above
Yes, sir.
the horizontal. It's above the horizontal. And when you think of the word elevate, elevate means what? Up or down?
Up,
Up. And depression means up or down?
down,
If you depress, don't you feeling what?
down.
Right.
Down.
So elevate in regular English language, elevate is up and depress is what? Down. It's the same thing here in terms of just making that connection. All right. So angle of elevation of B from A. Notice the picture. Notice the picture. All right. So A is right here. All right. So imagine that A is an ant on the ground. So A is not as tall as me and I. A is an ant right here. An ant is right at A. And B is up here. And the ant is right here. And so we draw a horizontal line lining up with the ants right there. All right. Good. B is right here. So the angle of elevation of B from A, the operative word right here, just like for bearings. The operative word here is what? From. Yes or no?
Yes, sir.
Because B from A and A from B are two different things, correct? So the word from is very, very important once again. So the angle of elevation of B from A is the acute angle above the horizontal. Above the horizontal, that we're going to pretend that the ants have some big eyes, that the eyes that the eye is raised from A to CB. So look at this picture. What we're saying, you're here, your ants, right, on the floor. I don't want to use a human being because a human being is tall, and then you're not going to be below the ground. All right. So in other words, your A would be right here if you're a human being and you're looking up, right? Looking up at some B, right? It's the same scenario here. So imagine your ants right here looking up at B. Then this angle here is your angle of elevation. This angle here is the angle of elevation of B from A. That means you start from the horizontal line through A. Everybody with me? So it's from A, it's from A, so the horizontal line go through A. And you measure from there up to the line that connects A to B. That's your line of sight now. So now it is angled. And so this angle here is what we call your angle of elevation. So you're looking up. You're right here, so you're looking up. That's why it's called an angle of elevation. Is that okay?
Sir, can you repeat, please?
So you're sitting right here. Let me draw something there, like a little box or something. All right. So you're looking up. That's not even necessary. Let me not do that. That's not necessary. You're right here. You're sitting at A, right? You're sitting at A and you're looking up at B. Then your line of sight, if you're sitting here, your eyes are right here. This is your line of sight, which is the same as the horizontal line. Yes or no? Yes? Your eyes are right here. And you look up. And you look up to B. You look up. So this angle that is formed between the horizontal and this line segment here is what we call the angle of elevation of B from A. You start at A, right? You measure from the horizontal line at A. You're looking up. So this guy here is your angle of elevation of B from A. So it is the acute angle above the horizontal that the eye is raised from A to CB. So you have to look up to CB, right or wrong? If you are here, you have to look up to CB, right?
Yes, sir.
Yes, sir.
All right. Now I'm going to do the same thing now. I change my color here for angle of depression. Let me change my color. Use a green here. So again, I am right here. I'm going to call that A still. All right. If I am here, then this is my line of sight, right? Remember now I'm ants on the ground at A. I'm ants, a little ants. So I am right on the ground. I'm living on the ground. So my line of sight is this guy here. Horizontal line. Which is the same as my line of sight. Because I'm sitting at A. Ants at A. Make sense? So my ants at A, I'm looking straight ahead. That's a horizontal line, right?
Yes, sir.
Yes. All right. Now, there is some B right here, so. And I know I'm looking down. I am looking down now. I'm looking down to B. So this angle here is called the angle of depression. Angle of depression. Okay? Of B from A. Right? Is the acute angle below the horizontal. As you can see in the picture, it's below the horizontal. Because the horizontal is right there. And this is below the horizontal, right? Below the horizontal. Let me write that. Below the horizontal. That the eye is lower this time. So elevation, you raise. Depression, you lower. So one of them is looking down, one of them is looking up. is lowered to CB. All right. So this angle here is the angle of depression. This angle here is the angle of elevation. I'm gonna, right, notice now, in both cases, notice, let me change my color here so that you can see this better. From, in both cases, what you notice with the from? From where? From where? Where are you
B
guys?
to A.
From where? From where?
A.
And this is also from?
A.
A.
All right, but notice one of them is depression and one of them is what? Elevation. So in both cases, you look this in the elevation, you're looking up to B. And in the depression, you're looking down to B. Make sense?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Wait me for a second now. I'm gonna give you a hypothetical situation which kind of drives home another point. What is my point I'm trying to drive home? I'm gonna put something on the iPad and you tell me if that is possible. Could this be true? Could that be true? That both
No,
angles
sir.
could it be true that both angles measure 30 degrees, for example?
No, sir.
Why
No,
not?
sir.
Why not?
Because one I look up and one I go down.
No, the size of the angle. Can it be still 30 in both cases? The size of it.
Yes, sir.
No, sir.
Yes.
Think about it. The person is saying no. The size of the angle, can't it be the same?
Yes, sir.
Yes, sir.
The
It
size,
can
just the
be
size.
same.
We're not worrying about the direction, just the size.
Yes, sir.
The size can be the same, correct? Both of them can measure 30 degrees, right?
Yes, sir.
Yes.
Right. But in this case,
Yes, sir.
this 30 degrees is an angle of elevation, right or wrong?
Correct.
But this 30
Right.
degrees is an angle of what?
Yes, sir.
Depression.
Depression.
So it's not about the size of the angle, it's about where, from where to where. It is your perspective. You understand?
Yes, sir.
Let me show you something.
Yes, sir.
Pay attention now. I'm going to show you something. I'm going to use this picture here that's already there. This picture that's already there. I don't have to change anything. All right. I'm going to draw in some stuff on the same picture that is there. Let me use purple.
Okay, sir.
So watch me now. Watch me carefully now. Watch me carefully. I'm going to draw a transversal there. Right? All right. And this is A. I'm going to call this A and call that B. Are you guys with me?
Yes, sir.
Good.
Yes, sir.
Watch me now, you know, because it's going to confirm everything. Everything's going to line up. Watch me now. Notice I did these guys separate, right? Watch me now. This is A and this is B, right? Yes or no?
Yes, sir.
And these two lines
Yes,
are
sir.
parallel, right or wrong?
Right, sir.
Correct.
Correct. So when you have a Z, tell me what you know from your geometry class. When you have a Z like that. This angle and this angle, what you know about them?
Are equal.
Sir, they are the same.
Ah, this angle. So I'm just gonna call it 30. If this is 30 degrees, I'm just gonna use 30. It doesn't have to be. I'm just using an example. If this is 30, then this have to be 30. Right or wrong?
Yes, sir. Right.
Correcto.
All right. Good.
Right.
So if so I said what I did here was perfectly correct, because if I am here and I am looking up to here, then this is my angle of what?
Elevation.
This is angle of what? Let me change.
Elevation.
Yes. If I'm sitting right here at A, so let me use some arrows here. And let me use some arrow there. So this one goes in that direction, right? And that one goes in that direction. All right, beautiful. Let me change my color here so we can see a little bit better. maybe I want to use which color here now? Blue, black. All right. So this angle here is the angle of elevation. Tell me what it is. Elevation of what? Of what? This one. This black one right here.
A
What?
from B.
Of what? Angle of elevation of B from A. Is that correct?
Yes, sir.
Right. And it measured 30 degrees, as you can see. And this one now, I'm going to change my color here just so we can just compare. I'm going to change my color to another color, like maybe use this blue here. So this one is the blue 30. So
Will
what
be
is that
angle
blue?
of depression.
This is
Angle
now
of
the blue is now
depression
the angle of
from
what? Angle of what?
Depression.
depression from A to
Of
B.
what?
A from B.
Of A, what?
From B.
From B. Beautiful. But both of them measure the what? The same size, right or wrong?
Yes, sir.
But
Right.
one of them is a what? Is an angle of depression based on where you're standing and looking. And one of them is an angle of what? Elevation based on where you're standing and looking. Make sense?
Yes, sir.
So your perspective is very important. The from is very important. Beautiful. So with that being said, let us go to the question now. All right, let us go to the question. So it says a person at the top of a lighthouse, TB. So this is a lighthouse right here, TB. Right, and the person is sitting right there at T. Make sense? And looking
Yes,
out,
sir.
looking out on the ocean, and they see two ships. One of them is S1 and one of them is S2, two ships. And the ships are approaching the coast. The tower is right here on the coast. And the ships are approaching, right? Good. As you see in the picture. So, right? So if your ants right here, let's call your ants. So you don't have much height. You don't have any height. So let us call your ants. This is your line of sight, right or wrong? If you're looking straight ahead. Yes or no?
Right.
Make sense? And this is the ground, right or wrong? This is the beach. The ground.
Correct.
Beautiful. The ocean and it line up with the ground, right? With the beach, right? Beautiful. And the ships are coming in. The angles of depression are 12 degrees and 20 degrees, right? Good, respectively. And the ships are what? 110 meters apart. So where should I put the 110? That's the easy part. Easy, easy. Where should I put the 110?
Between S1 and S2.
Beautiful. 120, right? 110. 110, right? Yes, 110. That's correct. Everybody agree with that?
Yes, sir.
Yes, sir.
So the two ships are 110 meters apart. All right, lovely stuff. Lovely stuff. All right, good. The ships, the angles of depression are 12 and 20 degrees respectively. All right. So the man, what is the angle of depression? We just spoke about it a while ago, right? So you're looking down, right?
Yes, sir.
Yes. So
Yes,
you're
sir.
looking you're sitting right here, and you're looking down to ship 2. You're looking down to ship 2. Right? So where's the angle of depression? If you're looking down, if you're sitting here, so line of sight is that if you're looking straight ahead. If you're looking down to ship 2, where's the angle of depression? Is it this?
Sir, under T. Yes, sir.
From the
Is it this, sir?
yes, sir.
Yes, sir.
That's the angle of
Yes,
depression
sir.
looking down to ship 2, right?
Yes, sir.
Yes, sir.
Correct. Right. So this is
Nice.
one angle of
Well,
depression right here. And if you're looking down to ship 1, this is
it's
also
12.
another angle of depression, right or wrong?
Correct, sir.
Everybody agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
With that.
sir.
Right. All good. So where should I put the 12 and where should I put the 20?
Sir, put the
12 will
12
be
at where you have the first arrow.
Yes, that's correct. And this one should be what?
For
Where
the
you have this.
second arrow is
20 degrees.
Yes, sir. Second arrow is yes, sir.
Right. Good. Lovely. Because obviously 20 bigger than 12, correct?
Yes, sir.
All right. All right. There's an error in the question, guys. And CXC made a mistake in the question. All right, I'm gonna correct it right now. And when I looked at the question earlier, I saw there's a mistake in the question, so I'm gonna correct it. CXC made a mistake in the question. So you agree with me that 20 have to be bigger than 12. So this one have to be 20, right or wrong?
Right.
Right, sir.
It's a physical impossibility. This one cannot be bigger than this one, have to be bigger than this one, right or wrong?
Right.
Right, sir.
This can be 20 and this be 12. That don't make no sense, right?
yes.
All right, so there's a mistake in the question. Let me tell you what the mistake is. I'm going to correct it on the screen in red and show you what the mistake is. This should be 20 and 12 right there. Take a look and tell me if you see why. Switch them around.
They had for S1 they had
This is you know, what does that word mean? Respectively.
orderly,
to
like from big to small or
So if I
something.
say, give me an example. If I say Jane, Tom and Jill have $10 and $20 respectively. What does that mean? Let me repeat. Let me write it. Tom and Jill have $10 and $20 respectively. What does that mean? Respectively. Who have $10 and who have $20?
Thomas
Tom
10 and
has
Jill has
$10.
20.
Beautiful. Tom have what?
$10.
Tom have the $10 and Jill have the what?
$20.
Beautiful. That's what we mean by respectively. Look at the question now. Go back to the question. Look at the question. It's a respectively. So who have the 20 degrees? Is it S1 or S2?
Yes.
Huh? The 20 degrees is for who?
S1.
S1. See there? And the 12 degrees is for who?
S2.
And which one did he state here first? Which one him state here first? Him say S1 and what?
S.
And S2.
Respective. So the S1 correspond to the 20 and the S2 correspond to the 12. You understand? So that was a mistake. It was an English mistake in the question, okay? But it's not going to change what we're going to do because obviously students, there's no way the 20 is going to be smaller than the 12. So everybody would have realized that this is 20 and that is 12, and it would not have affected the working out of the question, but there was an error in the language, all right? So we'll just switch these around. It's 20 and 12 and not 12 and 20 because he used the word what? Respectively, okay? So the S11 is 20, which makes sense because this is bigger, right? Makes sense? And the S21 is 12 because this is smaller. So with that being said now, we're going to go to the question. It says, complete the diagram by inserting the angles of depression and the distance. We already did that, right?
Yes, sir.
All right. So the next part of the question now. All right. Determine to the nearest meter. Determine to the nearest meter. The distance TS2. All right. TS2. So I'm going to label this distance here. Maybe I'll mark it a particular color. We want this distance, correct?
Yes.
Yes?
Yes, sir.
All right, I'm going to call it M, right? I'm going to call that distance M so we can work out for M, right? Everybody with me? We want M, right? Which is this distance here, which is TS2. Everybody okay with that?
Yes, sir.
All right. So, any ideas come to your mind? Think about it. You have M, and you have a right angle here. Any ideas come to your mind? Just anything come to your mind. Just tell me what come to your mind. You can always
The
adjust.
angle would that be 90 degree?
Well, this is 90 degrees. So what comes to your mind once you see a 90-degree triangle or triangles? Because we have one 90-degree triangle there, right? We have another one there with M. Correct? Or TS2. So trig ratios come to your mind?
You're finding the longest side.
No, what I'm just asking you, do trig ratios come to your mind because you have a right angle triangle? Yes or no? That's all I'm asking. I'm not asking you to solve the question yet. I'm asking you, would trig ratios come to your mind if you have a right angle triangle?
Yes, sir.
Yes.
Always.
Right. But we don't know if we need it yet. Let us see. All right. All right. So what is the man asking you for? He's asking you to find out what? M. He's asking you for M, which is a distance TS2, right? Everybody see that? This distance, right? Yes?
Yes, sir.
All right. So we have this distance, the M. We have this. What else do we have? Which triangle we want to use? We have a lot of triangles here. We have this triangle. That doesn't help us for M, this one. We have this triangle. M is in that triangle, or TS2. But do we have enough information? I don't know. Maybe not. And we also have another triangle, which is this one right here that I just draw. Everybody see that? Everybody see
Yes,
that?
sir.
Yes, sir.
All right. Which triangle you think that we may want to work with based on the information that we have? We have a lot of information. We have the 12 degree, we have the 20 degree, we have 110 here, and we want to find M. And we can find some stuff out. So I don't know. Take a good look. It's 3 marks for this question, I think. 3 marks. So that means you have to do a little bit of work, but it's not very difficult. Look carefully. Do we know this angle here, the one I'm marking on the screen? Do we know this angle? Yes or no?
No.
Take a good look. This one. This one. This little one here. Do we know what it is? From here to here is what?
Sir, it's 6
Yeah,
degrees.
20.
From here to here is 20. And from here to here is what?
12.
What is left over right here? So
Sir, when you subtract the 12 from the 20,
8.
you'll get the
beautiful. So we know that angle, guys. We know it. So this is 8 degrees right here. So this is 8 degrees. Agree?
Yes, sir.
All right. Good. Okay. What else do we know? So we know that. We can write it in right away. Good. What else do we know? So one of the things that I would encourage you to do when you get these questions, write in all information that you can know just from the question itself. Just from the question itself. All right. All right. So what else do we know?
a right angle.
Let me ask you a question.
is
Do we
in
know? All right. Stay with me now for a second. This one is not so obvious, but it's obvious now that I'm asking it. So watch me. I'm gonna do something. I'm gonna change my color here. Do we know? Can we find this angle here, the one that I've labeled magenta? This one right here, so that I've just drawn in. Can we find an angle there? Anybody know what that angle may be? Take a good look.
12 degrees.
Beautiful. Everybody see it? Remember a while ago in the previous
Oh,
question?
Z angle.
The Z angle right up here. So see it here? The Z angle When I did the 30 and the 30, the Z angle, same thing here.
Yes, sir. Z angle.
These lines are parallel. All right, so we have a Z right there. You see it? So this 12 and this is, guys, is the same. So these are, this is also 12. So this is 12. Everybody agree? Yes?
Yes.
Make sense? So if that is 12, then I know the third angle as well, right? If that
Yes,
is
sir.
12,
The AM, sir, 8 plus 12 subtract from 180 and get the next angle, sir.
beautiful. So this is what? 100 and what? 160. All right, good. So we have more than we need now, definitely. Think about it. All right, we have more than we need. All right, so this triangle here, look at this triangle now. The same triangle. Maybe I should shade this up a little bit more. Let me give it another color. Let me use which color here? Maybe let me use yellow. So this triangle here, right? That triangle there, which is this one, T, S1, S2. For that triangle, we have a lot of information. Look at it. Look at TS, triangle TS, triangle T,
Yes, sir.
S1, S2. Look at that triangle, right? We have a lot of information for that triangle. Look at it. We have this side, yes or no? 110, yes or no?
Yes, sir.
And we
Yes,
have
sir.
three angles, right?
Sir.
Right or wrong?
Yes, sir.
We have three angles, right? And we want to find M. So we have a lot of stuff we can use, right? Sine rule, maybe cosine rule. All right. If we can use the sine rule, there's no need to use the cosine rule because it's a little bit shorter. So we can use the sine rule definitely, right? Because we
Yes,
have
sir.
one.
Sir, I have two angles, sir.
Right. We have 1, 2, 3 angles. So we have more than we need. So we have 2 angles and we have a side, right or wrong?
Yes, sir. Correct.
Right, sir.
We want another side. So we have 2 angles, which is we have 3, but we need 2. Because remember it's A over sine A equal to B over sine B and so on and so forth. So we can use the sine rule. All right, so let us use the sine rule. So using, let me get rid of, I can write it right here. I can get rid of Jill now and Jack and do it right there. All right. So what am I saying here? Using the sine rule. All right. So 110 over the sine of what? So remember, I'm using this triangle here that I've labeled, that I've colored. TS1, S2.
S1.
So 110 over what? Sine of what?
160.
No, the 110 is across from which angle? The 110 is across from which angle? Is the 8. This angle, right? This is across,
Yes, sir.
this, right?
Yes, sir.
Correct? Yeah. Sine of what? 8 degrees. Equal to M now over sine of what? The M is across from which angle?
160. Yes.
All right. Sine of 160. And now we can use the what? The rule of 3 to find the M. Because the only thing that we don't know is M, right or wrong?
Yes, correct, sir.
Yeah, so we can cross multiply. Can cross multiply and this times that equal to that times that, right?
Yes, sir.
What we did earlier, coming right into play now.
We have
We can say
110
M
times sine
sine
160.
8 degrees, sorry, equal to 110 sine of what?
160.
degrees. So M is equal to what? 110 sine of what? 160
160.
divided by what?
Sine 8.
8 degrees. All right, tell me what the answer is. 110. What is sine of 160? Somebody tell me a calculator.
M equal 164.
No, tell me what the sine of 160 is. That's what I want. The sine of 160. Anybody? Practice a calculator. Sine of 160 is equal to
0.3420.
Thank you. 0.342. Let's use 0.342. And what is sine of 8?
0.139.
0.139. So we're good. So 110 times the 0.342, right? This is 37.62, right? Divided by 0.139. And this is equal to 270 approximately. 270.65. All right, that's what you guys got?
Yes, sir.
Beautiful. All right, so that's good. Let's see the other part of the question. The height of the lighthouse TB. All right, so we want now, I'm going to label this another color so we can look at it. Maybe I'll use this. We want the height of the lighthouse. So I'm going to use that color. So we want this distance here, TB, right? That I have labeled black. Beautiful. All right. What is the easiest way to do this? Anybody? Okay, you have a lot of information in that diagram. A lot of information. Remember your Z angles and all of that, right? And it's only 2 marks, so it's not a lot of work. What you want to use here? You want to use the right angle triangle? Yes or no? Wouldn't that make sense?
Yes, sir.
All right. So in the right angle triangle, do we know the other 2 angles? Do we know them?
Sir, the angle beside 160 is 20.
Beautiful. All right. So let's do that first. All right. We're going to do that first. The angle beside the
160.
160 is 20, as he correctly said. So this is 20 degrees. Angles on a straight line, correct?
Yes, sir.
All right. And good.
Sir, and then the right angle is 90 degrees. So you have the 90 plus the 20, and you subtract it from the 180 and get the next angle for T. Because a triangle sum up to 180.
Cool. All right. So you can do that. There are many ways you can do this, All right. But remember, what we want is remember, we want this side, right? Yes? Yes?
Yes, sir.
So which triangle are we using? Are we using this right angle triangle?
Yes, sir.
All right, watch me. This one or this one?
So the first one, sir.
But do you know this distance here?
No.
Ah, you don't know that distance. Do you know this distance? Do you know M?
Yes, sir.
Yes, sir.
Because we know M already, which is the hypotenuse of this right angle triangle. So we know M, right? This is correct, but it doesn't help you because we don't know this side, right? We can find it, but that will be too much work. It's a 2-mark question. So you're not going to waste time. But we already have this guy here. And we need this side. So we have hypotenuse. We have this side here. All right. And we have an angle. We have this angle here, which is 12, right or wrong? Yes or no? Let's go again. We have this side. We have this side. Sorry, we want this side. So this is involved. We have this side and we have this angle. we can use the trig ratios. Make sense? So stay with me now. In this triangle, right? In this triangle, we have the hypotenuse, right? Which is M. Yes or no?
Yes, sir.
So we have hypotenuse, and we want to find TB. What is TB? Adjacent or opposite?
Opposite.
Opposite to the what?
Opposite to angle 12.
12. This is opposite to the 12, correct? So we
Yes,
have
sir.
opposite and hypotenuse in a right angle triangle. Which ratio are we going to use? Opposite and hypotenuse. Which ratio are we going to use? Opposite, hypotenuse. Which ratio?
Sine can use, sir.
Yes, that's what I'm asking you. You remember SOHCAHTOA, right?
Sir, cos,
No, opposite and hypotenuse we have.
sin,
Sine, right? We're going to use sine because we have opposite and hypotenuse. Opposite and hypotenuse. You're going to use sine, right? You follow me?
Yes.
Remember, let me go again. Opposite to the 12. So that's opposite, and we have the M. That's the hypotenuse in the right angle triangle. So we want opposite, and we have the hypotenuse, so we can use the sine because we have the angle. All right? Make sense? All right, so let's use the sine first. We can also use cosine, but I'll show you in a minute. All right, so I'm going to write something now. Sine of 12 degrees is equal to opposite, which is the TB, over M. Everybody follow that? I'm going to write it right here again. Sine of 12 degrees is equal to opposite, which is TB, over hypotenuse, which is M. Make sense? So TB, which is the height of the tower, is equal to M cross multiply M times sine of 12 degrees. But we know what M is. What is M? M is 270.65.
270.65.
All right, and that was in meters, by the way, meters. So M is 270.65 multiplied by the sine of 12 degrees. And what is the sine of 12 degrees? Somebody can tell me what that is? Sine of 12 degrees multiplied by the 270.65.
Sir, I get 56.27.
That sounds correct. $56.27. Beautiful. All right. 56.27 meters, I think it is. All right, good. All right, so that is that. What else can we use? All right, so let me ask you a question. Watch me now. Watch me now. Let me use black. Do we know this angle here? This black angle that I just, that black angle. Do we know that angle? That black angle.
Sir.
Do we know that angle? That black angle that I just wrote in a while ago.
Yes, sir.
What is it?
Well, hold on.
sir,
Let me.
1820.
70 what? 8. Can you have to subtract it from 9?
78.
Because notice that this angle is
Sir,
at
the 90 plus the 1 plus the
90.
20, subtract 180. You get the small part plus the 8, you
the
get
20.
78.
That's true. That's true. Because it is this angle, right?
Yes,
but
sir.
Notice what I did from here to here. And this is 12. So this is 78 because this is a right angle, right?
Oh, yes, sir.
There are many ways of looking at it. What you said a while ago was not incorrect at all. But easily, from here to here is what? All of this is a right angle, correct?
Yes, sir.
You already have this piece, which is 12 to there. So this piece here has to be 78, correct?
Okay.
All right. That's one way of looking at it. Just one way. All right. So why am I doing that now? I'm going to use a 78 now to find this guy here because I'm using this right angle triangle. Remember, I still have M. Pay attention now. I'm using this triangle same way, the same triangle. But instead of the 12 degrees, I'm using the what? The 78. You understand?
Yes, sir.
So if I'm using the 78, the TB is what now? Is next to the 78. So it's adjacent, right or wrong?
Correct.
So which trig ratio I'm going to use? Cosine. Yes?
Yes, sir.
So I can say cos of 78 degrees. Cos of 78 degrees is equal to adjacent, which is TB, over the hypotenuse, which is what? Which is M. So M is equal to, sorry, TB is equal to, cross multiply, you get TB is equal to M cos 78 degrees. And you're going to get the same answer, which is what? 56.27. You can check it out for yourself, guys. Put in cos of 78 on your calculator and multiply by the 270.65, which is M, and tell me what you get. Tell me what you get.
So same 56.27.
Beautiful. So you see, we can attack this problem from many angles, right? 'Cause you have a lot of information there with those parallel lines and transversals and right angle and all that good stuff. All right. So many ways in which we can do this. All right. So we have one more to do. I'll go back to, so that was the last one here. I'll go back and quickly go through this one, this bearing one, which since we already did bearings, so we already understand the concept.
Easy, like a peasy.
All right, let's do this. All right. So it says, somebody read the question for me, please. Somebody read the question for me, please.
A ship sails from point A to point B, which is 15 kilometers from A on bearing of 04 degrees, whatever. The ship then sails to point C, which is 19 kilometers from B on the bearings 130 degrees. The following diagram shows a sketch of the ship's journey.
So on the diagram, insert the bearings 042 and 130. So tell me what to do. Where you think I should put the 042? And all right. And where I should put the other one. Very easy. So, oops.
Sir, the bearing of A is 042.
So it's from A. So you start at A
From
is 42, which is an acute angle, right?
Yes, sir.
042, yes? 42 degrees, yes?
Yes, sir.
So if this is 042, based on our take, all right? So let me use a different color here. Then this is 042. All right? So it means that this now has to be B, correct? Because the 042 is what? It sails from A to B, right? And B is from A, right?
Yes, sir.
15 kilometers. So so it means that this distance here is a 15 kilometers from A to B. That's the distance between the 2 points, right?
Yes, sir.
So this is 15. So we're going to write in 15 here. All right. 15 goes there. Make sense? So this is
Yes,
a
sir.
north.
Sir, and
This is the north line at B.
the
And then
angle at side B is 130 because it
130.
says
So right. So it means that let me change color here. That's fine. I'll use that color. So from B now, the north line is right there. So I have to go here. If I go here, then and this is what? 120,
130.
130. Then means that this is
The
C.
distance from B and C is 19 kilometers.
North line at C. And then this distance here is how
It's
much?
19 kilometers.
19 kilometers. So this is 19 km. That distance there from B to C. So right away, that is what they're asking us for. Good. It says now, calculate the distance between town A and town C. The distance between town A and town C. So what we want is this distance here, right? Let me label this distance here. All right, use that color, change my color here to probably red.
Requires the back bearing.
No, we want a distance.
No.
Distance.
Oh, distance. Oh, my bad. My
Distance.
bad.
We want this distance. All right. Good. We want that distance. Okay. All right. So I'm going to call that distance B. Little b. Since we across from it is big B. So I can call this little b, right? Yeah? That's okay? Yes?
Yes, sir.
All right. Good. So what do we know? What do we have? We want B. So look at the question. We want B, which is this. And what do we have? We have this side and we have this side. So it's three sides involved in the picture. This side, which we know, 15. This side, which we know, 19. This side, which we want, which is B. So if we have three sides and we have an angle, if we can know an angle, then we can apply the cosine rule, right or wrong?
Right.
All right, let us see if we can find this angle here. Can we find this angle here? Do you think we can find this angle?
Yes, sir.
Yes. We have this angle, right or wrong? This angle right here.
Yes, sir.
Right.
Do we know this angle?
Yes, sir.
How we did it
Sir,
earlier?
subtract the 42
What are
from
these angles
180
called?
and get the angle there.
These angles
So
are
them,
called what? Co-interior angles, right? So this is
yes,
what?
sir.
What is this one? Let's write it in quick. You see, that's what I say, write in as much as you can. So this is now what? 42 from what? 180, which
180.
is 38. Make sense?
Yes, sir.
So B is what? 92. 92?
Yeah. 130. Yes, sir.
Everybody has to add up to 360, right?
Yes, sir.
This is 130 already. We know that. We just found this as what? 138. So this is 92. Everybody add up to 360. So now we look like we're in business. We can use this. We can use what? We can find B. because the angle opposite B, we know it, which is 92. So we can use the cosine rule. So this is SAS, or side angle side, right? Side angle side. So let's do that quickly. So B squared, so cosine rule, is equal to what?
A squared plus C squared.
15 squared plus what? 19 squared,
15
right?
squared
Minus 2
minus
times
2,
15 times 19,
19.
right? Times the cosine of 92 degrees. So this is equal to 225 plus 361, 9 is 81, yeah? Minus 570 cos of what? 92 degrees.
92.
So this is equal to 586 minus 570 cos of 90 degrees. What is cos of 92 degrees, somebody? This is 586 minus 570. Cos of 92 is going to be negative. What is it?
Negative 0.034. Well,
Negative,
350 on the
negative,
top.
right? Negative 0.035. It should be negative, right? So this is 586 plus 19.89. When you multiply the 570 times that, negative times negative give you positive, and we get 19.89, right? Correct? So B is equal to the square root of 605, the positive square root. And this is approximately equal to 24.61. Tell me if that's what you got, guys.
Yes, sir.
All right, good. Lovely, lovely, lovely. All right. So this other part now requires some more work. It's 3 marks right here. Determine the bearing of town A from town C. All right. A from C. So I'm going to draw that in. A from C, we know what from C mean. All right, so let me use this color. So C from C. So this is the line CA starting with the north line. So this is what we want, right? Bearing. I don't need to write that. We know what we're talking about. This is A from C.
So there's a Z angle and the 92 at B, you should go at C right there, and then we use the back bearing to find the distance from C to A.
All right, let us see. All right. Why would you use this? Why would you use the back bearing? We don't know the bearing.
Sorry, Z angle, so 92 at B would be and the 92 at C up there.
Repeat.
I'm correct. The 92 degrees at B should be at C. The interior part at C.
No, no, no.
Look at it. Hold on.
No, 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 no. This, oops.
Bam, bam.
Gosh, my pen has died. Fortunately, guys.
So 92.
I've been writing so long. My pen is on 0 for a minute. All right, so yeah, it's a little bit more involved than that. Let me talk a little bit while my Apple Pen charges up a little bit. All right, so this angle, the angle here between the north line at C, all right, and BC. So look at BC. That angle there is 50 degrees. Do you agree?
Sir, where you get the 50, sir?
The one at the top is 130.
Oh.
And it's parallel. The north line at B is parallel to the north line at C. And the angle there is 130 at the top. So the other angle down there, their supplementary should be 50, correct?
Yes, sir.
All right. Let's see if it helps us, right? All right. What we want to find though, yeah, I'm making my pen to charge up a little bit, guys. So I'm just talking here. If we can find angle, we can find angle ACB. Can we find angle ACB? ACB. ACB. That means that angle C there inside the triangle. ACB. Angle C. Can we find that angle? Yes, we can find that angle because remember we have all the sides, right? We have all the sides, don't we? Don't we have all the sides? We have B and we have the 15 and the 19, correct? Correct? And we have 92 inside. So we can find angle C inside, angle ACB. Are you guys following me? Are you hearing me?
Yes, sir.
All right, so let's go again. We have the 15 and the 19 and we have B, correct? Look at the diagram, guys.
Yes, sir.
Look at the diagram. Don't we have B 50? We have all the three sides, yes or no?
Yes, sir.
And we have the 92 degrees, right?
Yes, sir.
So can we find the C angle in that triangle, the C?
Yes, sir.
Yes, we can find it, right? We can find C. Okay, cool. And if we find C, then we're in business. We can find the back bearing because we know that the angle there, we have the 50 degrees as well, right? Okay. So let us do that. Hoping I get a little charge here. All right, so it looks like I got a little bit of juice quickly. All right, let's do this before. All right, so what I was saying, I'm gonna call this is C. All right, this angle here, let me call it, yeah, that's my C. All right, now let's use the sine rule. Let's use the sine rule because we have all the information that we need for the sine rule, as you know. So we can go 15 over the sine of C is equal to, and we know what B is, right? Is equal to B over the sine of 92 degrees. All right, and B is what? 24.61 over the sine of 92 degrees. Now we can make sine C the subject, so sine C times 24.61, if we cross multiply, is equal to 15 sine of 92 degrees. So sine of C is equal to 15 sine of 92 degrees divided by the 24.61. And this is going to give you 0.609. And so we can find C. So C is the sine, inverse sine of 0.609, which is approximately 37.52 degrees. So this is 37.52 degrees. All right, and we have this angle already, which is 50 degrees, correct?
Yes.
Correct? Correct, guys?
Yes, sir.
Yes, sir.
So what is the bearing then, all right? So the bearing of A from C is 360 minus the 50 plus the what? 37.25, right? 37.25, which is equal to 360 minus, what is this? 87.25. What is that? So what is the final answer? 360 minus 87.25 equals to 272.75 degrees. Right. So that's why it was worth 3 marks. So you have to do a little bit of work, right? You have to do this first, and then the other part was pretty easy. Because once you got this angle, so this wasn't much work because you knew this. So this wasn't much work. But so you have this piece here, you want all of this, so you can find this angle because you have all this information, right? You have B, you have the 15, you have that, you have the 92. You have options, all right? You have several options, all right? So I use the sine rule here to find the C. And once I have C, I have this piece, I have this piece. I'm in business, I can find my bearing. And that is
Sir, no 5-2, why you have 2-5?
7.5. Where is that? 37.52.
At the bearing.
Oh, thank you. This one right here. Oops. This should be 2.5 or 5.2. Here. Which one?
5-2.
Is 5.2
Yes.
2.5 or the other way around?
37.252. I have 2-5.
So this should be 5.2. This one. 5.
Yeah.
Correct? Okay. So this is 5.2. Thank you. So this is 5.2. So that won't be 75. That would be what? 52, 48, right? Degrees. Yeah, 48 and 52. Okay. So that should be fine. All right. So with that, I know it's been a long, 3 hours. So, but we're done for today for this part A of your exam prep session. So you can always go back and look, and even probably maybe, I don't know if you have option to download the notes or snap pictures or so on and so forth. All right, but I hope this was very useful for you guys as you prep for your CSEC examination that's imminent. And I wish you the very best of, not just luck, but luck in the sense that, what you study comes and what you're prepared for and understand comes, and that you remember in that sense. But preparation is what it's all about, and that's what you're doing now. And if I can gauge your future performance by how you have responded today, those of you who are interacting with me actively, I would say that you're on the right track. So just keep on doing what you need to do, what I know your teachers are reminding you to do on a daily basis. Just keep doing and practicing and revising, all right? And you should be fine. All right, with that being said, thank you very much and all the best.
Students, let
Okay,
us
sir.
give
Thank you.
Dr. Ajani thumbs up. We think he did a really good job this evening. He took us from 5:30 straight up to 8:40. I'm seeing the love. I'm seeing the love, students. Thank you so much. We want to really say thanks to Sir. Today is our first session, as Sir shared earlier. Part 1. So we have part 2 of geometry and trigonometry on Thursday. That's the day after tomorrow. Same time, 5:30 p.m. Same link. And remember, you have the booklets. Work the questions before you come to the session so that the sessions can go a little bit smoother and faster. On Thursday, today, Dr. Ajani would have focused on bearings, the trigonometric part of question 9. On Thursday, our presenter will be looking at circle theorem, that is the geometry part of question 9. So please don't miss it. If your friends are not online and you know they too are sitting the CSEC math exam, please bring them along with you on Thursday. All right, you are pretty much home. and we are working through some exam questions with you so you get as much practice as possible, and so you are very well prepared to sit your CSEC exams, which will be on May 12th, 2026. So all the best. Thanks so much for joining us this evening, and we look forward to you all and your friends and families back here on Thursday at 5:30 p.m. Take care, everybody. Thanks, sir.
Welcome. And thank you, guys.
Thank you, sir.
You're welcome.
Thank you, sir.
Bye bye.
Sorry,
Guys.
can I go back down to the last bearing questions?
The last, you want to see the last bearing one? Okay.
Yeah, the last one that we did.
All right, let's slide down here.
That one.
All right.
Okay. Okay, thank you.
You want to see the other part?
All right. Yes, sir.